In this course, you'll learn what Kubernetes is and why you would choose to use it. We'll cover the history of Kubernetes, the fundamentals of Kubernetes architecture, as well as key terminology that you're bound to encounter when delving into the world of container technology. We'll take a look at the deployment options and explore how we can run applications with Kubernetes, including monitoring, scaling, and storage. We'll cover administering Kubernetes, including how to use the Kubernetes dashboard, managing resources, and what to do when the unexpected happens with troubleshooting pods and nodes. This course has been designed to be very hands-on, so you can expect a lot of learning through labs, a step-by-step guide on how to get started with Kubernetes, and when you complete the course, you'll be ready to dive deeper into getting the most out of the increasingly popular container orchestrator. I'm excited to help you learn the fundamentals of Kubernetes, so grab your favorite beverage, sit back, and enjoy the course.
Hello, Cloud Gurus, and welcome to my course, Kubernetes Fundamentals. In this lesson, you'll learn why Kubernetes is so important, why you should learn Kubernetes now, and how learning Kubernetes can help you. We've got a lot to cover, so let's get started. If you ask me, Kubernetes is booming, but don't just ask me. Ask around, ask your fellow administrators, ask at the user groups. Heck, you can even ask those industry analysts, because what they say is that of companies that are using containers, 84% are using Kubernetes for container orchestration. You'll also find out that of companies that are using Kubernetes, 58% are using it in production. And finally, production growth in cloud-native applications has increased by 200%. These statistics are from the Cloud Native Computing Foundation's Cloud Native Technologies Survey. And you might be saying, well, statistics are great, but I mean, what's really in it for me? Well, for most of us, in some way, shape, or form, it's our job to run applications and to run them well. And containers, when managed and orchestrated by Kubernetes, are the most efficient way to run your company's critical applications. You'll get the massive scalability, availability, and modularity that most administrators and developers just dream about. Kubernetes is also backed by a robust open source community. That's going to give you a strong ecosystem of content creators, bloggers, authors, training classes, integration partners, consultants, and software developers, all cranking out resources to help make your life as a Kubernetes user far easier than if you had chosen some other orchestration solution. And finally, knowledge of and experience with Kubernetes is going to give you a strong career for the future. Companies are looking to migrate their applications to Kubernetes, and there's rapidly increasing demand for anyone with Kubernetes experience. Now, I said we've got a lot to cover in this course, and it is absolutely true. Let me review with you quickly exactly what you'll learn by watching this course. First off, the course is broken up into 4 different sections. We start off with an introductory section, and that's where we'll cover, just very briefly, the history of Kubernetes. Where did this product come from and who dreamed it up? You'll also learn the architecture of Kubernetes and the terminology that goes along with Kubernetes. The second section is where we'll deploy Kubernetes. You'll learn how to use Kubernetes in Docker Desktop, the Play with Kubernetes website, how to run MiniKube in Windows, and MiniKube on Mac. There are so many different ways to deploy Kubernetes, and you'll learn about some of the most popular. In the third section, you'll learn how to run Kubernetes, specifically how to deploy applications, how to monitor those applications, scale up your applications, leverage services, Kubernetes storage, and how to update your applications over time. And finally, the fourth section is administrating Kubernetes. You'll learn about the Kubernetes dashboard, getting a shell in a container, managing resources, troubleshooting pods, troubleshooting nodes, and using the Kubeadm tool. It may look like a lot, but we're going to fly through it and make it fun. Before we do, let's talk about some prerequisites. Now, before you get started in this course, there are a few things that you need to know about. First off, knowledge of containers is very helpful. If you don't know what a container is and what Docker is and how to run a basic container, then I encourage you to first go learn more about that here at A Cloud Guru before you learn about Kubernetes, because Kubernetes is all about running containers. So you need some basic container knowledge. I also recommend that you have some Linux command line knowledge. We'll be spending quite a bit of time at the Linux command line, moving around the file tree with things like cd and ls, and then editing files with tools like vi, vim, nano, or whatever your favorite text editor is. And then finally, make sure that you bring your interest in learning Kubernetes, because Kubernetes is an incredible tool, and that enthusiasm and interest in trying out Kubernetes for yourself on your own desktop or laptop computer is going to make a huge difference. But keep in mind that since this is a fundamentals course, there isn't a tremendous amount of knowledge that you already need to bring to the table. So with that in mind, sit back, relax, and enjoy the course. Hello, Cloud Gurus. Before we jump into anything, it's always important to have a little perspective. And I promise you I won't bore you with a crazy long history lesson. But what I want you to know is where this Kubernetes thing came from and how did we get from there to today. The Kubernetes timeline starts back in 2003, about 16 years ago at the time of this recording, with something called Borg. Now, if you haven't heard of Borg, then you haven't watched much Star Trek: The Next Generation. The Borg were an advanced alien race that was set on controlling the universe and assimilating the human race to turn them into minions of the collective. And the goal of the Borg was to achieve perfection. So why am I telling you this? Well, if you've used Google Search, Gmail, and Google Docs, then you've benefited from Google's Project Borg. It was aptly named Borg because it controlled hundreds of thousands of containers that ran on minion nodes and was always trying to achieve perfection. However, that perfection was defined by the Google engineers. Now, Borg evolved and improved between 2003 and 2013 into something called Omega. And at that time, Google wrote a white paper on it and introduced it to the public. Then in 2014, Google chose to open source a spin-off of Borg and Omega's internal cluster management system. Initially, that project was called 7 of 9 in reference to the Borg that joined the crew of the Star Trek Voyager. When officially open source, the project became Kubernetes. And as I said, Kubernetes is Greek for helmsman or pilot of a ship. And that's apropos because it is the pilot of your containers and your cluster that it orchestrates. So if you look at the Kubernetes logo, you'll see that the ship's wheel in the logo has 7 sides in reference to 7 of 9, the Borg from Star Trek. Then in 2015, version 1.0 of Kubernetes was released, and along with the Linux Foundation, Google created the Cloud Native Computing Foundation, also known as the CNCF. At that point, many companies joined that ecosystem, and the inaugural KubeCon, or Kubernetes Conference, was held. After that, Kubernetes has had one release and one advancement after another. For example, in 2016, Kubernetes went mainstream with many production features, including custom resource definitions, storage improvements, and Windows Server support. Around 2016, MiniKube, which is used to bring up small Kubernetes environments, was also released. In fact, we'll be spending a fair amount of time in this course using MiniKube. And then in 2017, a number of new advancements were made. Amazon and Microsoft both announced their own managed Kubernetes service, Oracle joined the CNCF, Docker announced support for Kubernetes, and more. And then in 2018, Google Kubernetes Engine was released, Amazon EKS, or their enterprise container service, was made generally available, and so was Microsoft's AKS, or Azure Kubernetes service. That same year, Containerd, which is the container daemon, became generally available, and it fully supported Kubernetes. That same year, Kubernetes version 1.10, 1.11, and 1.12 were also released. And what's amazing is that by 2018, more than 50% of the Fortune 100 companies are using Kubernetes as their container orchestration platform. Fast forward to 2019, the year that this course was created, and versions 1.12 through 1.15 roughly have been released, with Kubeadm, which is the Kubernetes administrative tool in general availability. The Container Storage Interface, or CSI, is now GA, and there's support for Windows nodes as part of a Kubernetes cluster. I'm excited to say that the adoption and the advancements continue to skyrocket forward. So it's a great time to be learning Kubernetes. And now that you know where Kubernetes came from, let's learn exactly how Kubernetes is architected. I'll see you in the next lecture. Hello, Cloud Gurus. Let's talk about container orchestration. The Kubernetes architecture has been designed perfectly to orchestrate your containers. And I can tell you that it can get quite complex. But in this fundamentals course, I'm going to try to sum it up for you as quickly and as efficiently as possible. The first piece of any Kubernetes architecture is going to be the master node. When you initiate your Kubernetes cluster, you're going to bring up this master node, which is usually a separate physical or virtual machine. It's the master node that serves as the control plane for Kubernetes. You can think of it as the manager for the entire Kubernetes cluster that makes sure that all the containers and all the workloads are running at their most perfect optimal state as defined by the Kubernetes administrator. In Kubernetes, all communication to and from the master goes through the API, or the Application Programming Interface. That includes the graphical dashboard, any command line interface tools like kubectl, which is also sometimes pronounced kubectl or kubecontrol, and other API communication to and from the kubelets, which are the agents that are running on each node. On this master node, the scheduler is brought up, the controller manager, and of critical importance, etcd. etcd is a distributed database, and it's the only stateful piece of the Kubernetes master. And in production environments, you would create a highly available etcd cluster as well as multiple highly available Kubernetes masters. Once you have the master node initialized, you bring up as many nodes as you would like. These nodes used to be called minions, which I actually prefer better. I also prefer the term worker node over just node, as these nodes are really what's going to do all the work for you when it comes to running your containerized applications. But in Kubernetes, they're typically just called nodes. But you should keep in mind that the nodes are what actually do all the work of running your containers. Now, on each of these nodes, you'll have a Kubernetes agent called a kubelet, which is used to communicate with the API server on the Kubernetes master node. You'll also have a kube proxy, which is a network proxy service. You'll have a container runtime, such as Docker, and then from there, your applications are going to run inside containers, usually Docker containers, and those containers run inside Kubernetes pods. To administer these containers running inside the pods, you're going to use the kubectl command line tool to tell the Kubernetes master how many pods you'd like to have running at all times and instruct the kubelets on each node to make it so. So it's the master scheduler that's constantly checking to see what the current state is of the nodes and the pods, and to take action if the current state doesn't match your intended state, which is also commonly known as your desired state. So that's the Kubernetes architecture at a high level. Now, when you finish this course, if you want to learn about Kubernetes architecture in much more detail, I recommend that you watch Nigel Poulton's Deep Dive Kubernetes course here at A Cloud Guru. But for now, I hope that you'll stick with me because we have one more lesson on the Kubernetes terminology before we jump in and we install Kubernetes and start bringing up our own master, our own nodes, and our own containers running inside pods. I'll see you in the next lecture. Hello, Cloud Gurus. Kubernetes has its own terminology, so if you want to use Kubernetes, there are a few terms that you first need to be aware of. Now, I promise that this is the last bit of theory before we jump in and start using Kubernetes. And even in this lesson, I'm going to periodically jump out to the command line into the lab and show you how these terms are used in the real world of Kubernetes, and I encourage you to follow along when I do so. We've got a lot of cool new Kubernetes terms to learn. Let's get started. Cloud-native applications running in microservices architectures are popular topics because they give businesses greater flexibility, greater scalability, greater availability, and the agility that the company needs. They also provide a lot of flexibility to developers. But what exactly are microservices applications, and what do they have to do with Kubernetes? If we step back and talk about traditional applications are very monolithic, where they consume a ton of resources to run their own operating system, authentication, web server, middleware, database, and analysis, perhaps, all on the same virtual machine or physical server. These applications are difficult to upgrade, they're difficult to scale, they're difficult to make highly available, and these are all things that the business needs. For greater agility, efficiency, and scalability, companies are moving to these microservices architectures. So the same type of monolithic traditional application can be broken up into this microservices application, where those same services are being run, but in this case, they might be run inside individual containers. For example, authentication, web server, middleware, database, and analysis can all be run inside individual containers with different resource allocations or multiple containers. And that way you can easily scale up or down individual services. You can also upgrade individual services or replace individual services. However, as you might guess, this also increases complexity if it's done manually. It's Kubernetes that makes these microservices architectures and applications possible and enables the next generation of cloud-native application. So for the future, both the business and developers want these microservices cloud-native applications, but they need container orchestration to make them possible. So exactly what does container orchestration do? Well, Kubernetes is a container orchestrator, and it optimally runs your workloads. It provides access to needed storage and networking resources. It ensures the applications run with the business intent. That means that I can say, I want 10 database servers, 25 web front-end servers, and 13 analysis servers all running inside containers. And Kubernetes will ensure that that is always the case. If one of those services fails, it will automatically restart another service to ensure that the application is always configured and running with the business intent. And by doing so, it provides greater efficiency for the developer and the administrator, high availability, and load balancing. For example, let's say we have a 3-node Kubernetes cluster. Each of these nodes is running 2 pods which contain a single container each, providing a capacity of 6 total containers running the business application. And let's say that one of these nodes fails. It has a physical failure, the power is off, it crashes, whatever it might be. Kubernetes will realize that the business intent of having 6 pods running at all times is not being met, and it will automatically restart the failed pods on the remaining nodes. So again, container orchestration provides high availability, load balancing, because inbound connections can be distributed automatically across all the nodes that are running the workload, resource management, and desired state configuration through a declarative model, meaning you define exactly for Kubernetes what you want to be running at all times, and it will ensure that it is indeed running. The next term I want to talk about is a cluster. In the world of Kubernetes, a cluster is a collection of nodes, also known as hosts, storage, and network resources that are used to run your workloads. You may have one or multiple clusters, and every cluster will have at least one Kubernetes master. If we take a look at our diagram, this is the typical cluster here. You have a master node, which we'll talk about more in just a minute, and then a worker node, or just a node as it's called in Kubernetes. And in production environments, you would probably have multiple master nodes and many worker nodes that actually run your workloads. Here at the command line, if I type kubectl get nodes, you can see we have a single node in this cluster. The name of that node is MiniKube, its status is ready, and it is a master node. We said that the Kubernetes cluster is made up of a master node and then just a node or a worker node. It's the master node that's the control plane of Kubernetes. and it's made up of a number of different components, such as the API server, the etcd key value store to store all the stateful Kubernetes data, the Kubernetes scheduler, the controller manager, and the cloud controller manager. The role of the Kubernetes master is to schedule workloads in the form of pods and handle all events. Again, it's the control plane, it's the manager of the entire Kubernetes cluster. It could be a physical host or it could be a virtual machine, and it could be running on premises in your own data center, or it could be running in a cloud instance. Again, the most important components of a Kubernetes master are the API server, which is constantly talking to the worker nodes in the cluster, as well as the kube control command line tool and other tools that Kubernetes is integrated with. The scheduler, which schedules new workloads on the nodes in the cluster, the controller manager, which ensures that the workloads that are being controlled are running as they should, and then the etcd database to store all the stateful data that's relevant to keeping these workloads running. If we jump to the command line and run kubectl get pods, and then use -- all namespaces, and we'll talk about namespaces more in just a minute, you can see that we have a number of pods running, and each one of these has a container inside, but you should see here the different services that make up the Kubernetes master. There's etcd, the API server, the controller manager, the scheduler, and a number of other optional Kubernetes master services. In Kubernetes, we have a number of different namespaces. Namespaces are a logical abstraction of the Kubernetes cluster that allows you to support multiple virtual clusters, and you use resource quotas to manage the resources that are consumed in each of the namespaces. There are 3 different default namespaces: the default namespace, kubesystem, and kubepublic. When you run a workload in Kubernetes, it's going to run in the default namespace by default. All of the control plane services that make up the master are run by default in the kubesystem namespace. If we take a look at a diagram, here we have a Kubernetes master and 3 nodes. Each node is running a number of pods, but if we wanted to, we could create a resource quota and allocate just certain pods to a specific namespace. Perhaps you have a group of developers who are developing a specific application. You want to make sure that they don't interfere with perhaps production applications that might be running in the default namespace, or vice versa. You can create multiple namespaces. You cannot nest namespaces, but they make a very convenient logical abstraction instead of you seeing every workload that's running across the entire Kubernetes cluster. For example, here at the command line, if we type kubectl get namespace, you can see all the namespaces that are configured on this Kubernetes cluster, including default, kubepublic, and kubesystem. And then we have nodes, and we've talked a little bit about nodes already, but nodes are controlled by the master. It's these nodes, or worker nodes as I like to call them, that are made up of a few components such as the kubelet, which is essentially a Kubernetes agent, so it can communicate and work with the master node via the API server, the kube proxy, which is a network proxy that runs on each node, and then the pods themselves, which are essentially wrappers around your containerized workloads. And it's important to note that in the past, nodes were called minions, a name that I like much better than simply node. So if you see any old documentation or content that refers to Kubernetes minions, just know that they're talking about nodes. A node is a single host, and it could be a physical host or a virtual machine, and it could also run either on-premises in your data center or up in the cloud. If we look at our diagram here of the master with 3 nodes, you can see that's an example of a node running the kubelet, kube proxy, and in this case, 3 pods, which contain our containerized workloads. Back here in the lab, if we type kubectl get nodes -o equals wide, we get some more details here. You can see, again, the name of this node is MiniKube. Its status is ready. It's a master node, but we also get information on the Kubernetes version, in this case 1.16, and we can see the container runtime is Docker. And then the final term before we start our deployment of Kubernetes is pod. Now, a pod is the unit of work in Kubernetes. So a pod is what runs your applications, and those applications are the whole reason that you're running Kubernetes to begin with. Pods contain containers, and those containers contain your applications, whether it's a web server, a database server, or some analysis server. A pod can have one container or multiple containers, but typically administrators just run a single container inside a pod. All containers in a pod have the same IP and they can communicate with each other. And they also have access to the same shared storage. Pods are identified by a unique UUID. And if we take a look at our diagram here with our Kubernetes cluster, where we have our master node and 3 worker nodes, you can see on each of these worker nodes, that's where we're running our pods. Inside those pods are our containers, which contain our applications. And the typical microservices architecture would dictate that a single application for the business would be broken up across multiple pods and multiple containers, just like we talked about at the start of this lesson, where you might have multiple web server pods, multiple database server pods, a few authentication server pods, some logging server pods, and they're all orchestrated or distributed across the cluster thanks to Kubernetes. Back here in the lab, and I encourage you to follow along if you'd like, you can type kubectl get pods, and in this case we haven't started any pods, right? We're not running any pods yet. However, that's in the default namespace, which is a term we talked about earlier. If we wanted to get all pods across all namespaces, we can use this command, which we ran earlier, get pods -- all namespaces. And you can see there we are actually running many pods in this Kubernetes cluster. However, these are all in the kube system or Kubernetes dashboard namespace. A little bit later in the course, we'll start up our first Kubernetes pod, and that pod will be running in the default namespace, which is where your pods are going to run, well, by default. And with that, we've reached the summary for this lesson. In this lesson, we learned a lot of different terminology as it pertains to Kubernetes. Specifically, we started off by talking about microservices applications, how monolithic applications more and more are being broken out into these microservices applications. And in order for those applications to be successful, they really need to be run in containers, and those containers need to be orchestrated. And that's the job of Kubernetes. We talked about how Kubernetes orchestrates those containers in clusters, and those clusters are controlled by master nodes. Now, you can logically segment your cluster into namespaces, and in fact, that's done by default with the kube system and the default namespace. From there, we learned how Kubernetes nodes are actually what run your containers, and how those containers are run inside the Kubernetes construct of the pod. Thanks for sticking with me all the way through this lesson on critical Kubernetes terminology. We're about to deploy Kubernetes, and it's going to be a lot of fun. I hope you'll join me in the next lesson. Hello, Cloud Gurus. In this module, we'll be deploying Kubernetes in a number of different ways. And the cool thing about Kubernetes is it's just software, and you can deploy it just about anywhere today. So let's talk about that. Where can you run Kubernetes? Well, you can run it in the public cloud in a variety of different ways. You can roll your own with your own instances on any cloud platform, on Azure, on AWS, on Google Cloud Platform or GCP, simply by creating a Linux instance and then installing Kubernetes. Or you can use a managed Kubernetes service that all of these cloud providers have made available, where they have created their own Kubernetes master control plane. They have their own worker nodes. They manage and scale that as needed. And essentially, you just define what it is that you want to deploy. Amazon has EKS, the Elastic Kubernetes Service. Google has GKE, the Google Kubernetes Engine. And Azure has AKS, the Azure Kubernetes Service. All of these managed Kubernetes offerings make running Kubernetes super easy, and you simply pay for what you consume. And then, of course, you can run Kubernetes on premises as well. You can install Linux on a physical server and then install Kubernetes on top and create a cluster of physical hosts to build a physical Kubernetes cluster. You could use virtual machines, of course, running inside a hypervisor such as VMware vSphere, Hyper-V, or KVM. And that's also a great way to build a virtual lab, a virtual Kubernetes environment. And there are numerous Kubernetes lab and testing options. For example, you can run virtual machines in VirtualBox, VMware Fusion, VMware Workstation, and others on your local desktop or laptop computer and build a Kubernetes cluster inside. You can use Docker Desktop, which now has built-in Kubernetes functionality. You can use the online Play with Kubernetes website, and it's super easy to deploy MiniKube on Windows or MiniKube on Mac. And I'll be walking you through all of these virtual Kubernetes lab options in this course step by step. But there are a few limitations that you need to be aware of. First off, Docker Desktop and MiniKube specifically create single node training environments, which are still very useful, but if you want to mimic a production environment, you would have multiple nodes, and that's not possible today with MiniKube, for example. And then on the other hand, if you run Kubernetes out on the cloud for testing and learning, you're going to have to pay based on your usage. And now there are some free tiers out there, as well as credits available that you'll want to make sure that you look into. And finally, if you choose to use managed Kubernetes like I talked about, for example, EKS on AWS and AKS on Azure, you'll be able to run your workloads and gain some knowledge with Kubernetes, but because you won't have access to the control plane and the master nodes, you might not gain all the Kubernetes experience that you'd like to. So with those deployment options in mind, it's now time to get started deploying Kubernetes. I hope you'll join me in the next lecture. All right, hello Cloud Gurus. A great way to deploy Kubernetes is to do it through Docker Desktop. So Docker Desktop is an application you install on your Mac or Windows desktop or laptop computer, and it comes in a couple of different flavors. It allows you to run not only Docker, but also Kubernetes, all in a single download. We're here at docker.com, and I encourage you to follow along with me as we do this. If we go to Products and then click on Desktop, you can see we can download Desktop for Mac or Windows. If we click on that, we're prompted to sign in with our free Docker ID for Docker Hub. And from here, you can easily download Docker Desktop for Mac or Docker Desktop for Windows. Now, I'm not going to go into Docker Desktop for Windows because honestly, the installation is very similar to installing Docker Desktop for Mac, and it's just the same as installing just about any other Windows application. Plus, we will go into ways to install Kubernetes in Windows in upcoming lessons. So I'm going to click Download Docker Desktop for Mac. That'll start the 650 megabyte download, and while that happens, I wanted to show you over here that there are a couple of different editions of Docker Desktop. But first, notice that it says Docker Desktop allows you to set up a certified Kubernetes environment. And if you scroll down, you can see there is Docker Desktop Community Edition and Docker Desktop Enterprise Edition. And they're very similar, but there are some differences here. So if you're a developer, you want to keep in mind the Enterprise Edition that's available to you, of course, with an upcharge, but it gives you full support as well as some other flexibility around choosing the Docker engine and the Kubernetes version that matches your Docker Enterprise Edition. I'll click the installation. And from here, we're prompted to drag the Docker app into our Applications folder. And then I'll click on Applications, find Docker, and launch the Docker app. We'll need to provide Docker Desktop privileged access. And from there, Docker Desktop will start up. They encourage you to enter your Docker ID and password here. And now it says Docker Desktop is up and running. If we click on the Docker Desktop icon, you can see that it is running. Let's click on About Docker Desktop and take a look at that. We're now running Kubernetes version 1.14.6, as well as Docker Engine version 19.03.2. If we go into Preferences, there are Kubernetes preferences here. And what we'll need to do to enable Kubernetes is to check the box that simply says Enable Kubernetes. And I also like to check the box to show system containers. I'll click Apply and Restart. And with that, you can see that Docker Engine and Kubernetes are now running. So if we click Cancel here, we should be able to open up our terminal, and let's just go to the command line, and I'll type Docker version, and you can see we have Docker Community Edition version 1903 there, and then we'll type kubectl version -o equals JSON, and you can see here the server version is 1.14.6, as well as the client version. So we are running Kubernetes here. We can also type kubectl get nodes and see that we do have a single node. It's a master node, and its name in this case is Docker Desktop. So that's how easy it is to use Docker Desktop to deploy Kubernetes. Now let me show you some other ways to get started using Kubernetes. I hope you'll join me in the next lesson. Hello, Cloud Gurus. Another great way to get started learning Kubernetes is to use the Play with Kubernetes website. This is a free website online in your web browser brought to you by the folks at Docker. And the great thing about this option is there's nothing to install, nothing to download. Simply open your web browser, and I encourage you to do this on your own. And I simply searched my favorite search engine for Play with Kubernetes, and the first option that came up is this website. And the actual website is labs.play-with-k8s.com. But as you can see, if you go to your search engine, you'll find it right here. So the cool thing here with Play with Kubernetes is you log in with a free login. Could be GitHub, could be Docker. Either one will work. Again, those are completely free accounts that you can get, and then simply click Start. And how it works is you have exactly 4 hours to play with this Kubernetes lab environment. So after 4 hours, everything you do here will be completely gone. So what I just did was I clicked Add New Instance 3 times, and I brought up 3 nodes in my Kubernetes environment. You can see we are at a command prompt. And what we can do is we can get started by initializing our cluster. So I can say kubeadm init, and that initializes the Kubernetes cluster. That's more advanced than we need to get into right now. But the point being that we can easily start using Kubernetes all in this virtual lab environment through our web browser. And it can take a few minutes to bring up the environment. And from here, if we clear the screen, let's type kubectl get nodes. And you can see there's our first node, which is the master. It's not quite ready yet, but that's how easy it is to bring up a virtual Kubernetes environment with the free Play with Kubernetes website. I hope you'll join me in the next lesson. Hello, Cloud Gurus. One of the most popular ways to deploy Kubernetes in a testing and learning environment on a Windows desktop or laptop is to use MiniKube. MiniKube is a super fast, super efficient way to get Kubernetes up and running in just a few commands. At a high level, the first thing that you need to do is to make sure that virtualization is supported and enabled on your desktop or laptop computer using system info. And I'm going to walk you through all these steps in just a moment. From there, you need to install a hypervisor if you don't already have one installed, such as Microsoft Hyper-V, VirtualBox, or even VMware Workstation Pro. After that, you install MiniKube and then start MiniKube. Now, the exact commands to do this are here. You start off with system info to check if virtualization is supported and enabled. And then I recommend that you use the Windows package manager called Chocolatey. If you haven't heard of it before, it's not just a fun name. It's a super easy way to install just about any application in Windows with a single command. So we're going to use Chocolatey to install our VirtualBox hypervisor and then MiniKube using Choco install. If you don't have Chocolatey already installed, I recommend you check it out. You can install it in a single command over at chocolatey.org. Once MiniKube is installed, we'll start it up with MiniKube Start. Let's go to the Windows command line and get started. I encourage you to follow along. Here we are on our Windows 10 desktop. This is actually a laptop running Windows 10, and I'm just going to open up the command prompt. So here on the command prompt, we're just going to start off with system info, And this pulls out processor, Hyper-V, network information. And what we're looking for here is at the very bottom where it says virtualization enabled in firmware, and it says yes. That's what we're looking for, that yes right there. So we know we do have Intel VT or AMD V enabled in the firmware, and that allows us to run virtual machines, essentially. The next thing we're going to use is Choco, which is the Chocolatey package installer to install VirtualBox. And that's going to be our hypervisor. And this first reminds us that we're not running an elevated command shell. And that's my reminder to you that you need to be running your command prompt or PowerShell, whatever it is you choose to use as administrator. So we're going to say no. We're going to close this out. And let's go back to the start menu and back into command prompt. And this time we're going to choose to run it as administrator. There we go. So now we have all the power to administer this system. And let's do Choco install VirtualBox this time. And because I've installed it once already, I know I need to use the -- force option. And now we need to say yes or A to accept running the script that it will execute. It's a PowerShell script. It will download VirtualBox. We'll give this just a minute. The download is complete and it says VirtualBox is installed. And of course, you could have also done that by downloading VirtualBox and using the graphical installer. Let's clear the screen. And now let's do Choco install MiniKube. And this will go through the same process. It will basically download MiniKube for us and install it. And it's that easy, really. MiniKube is now installed. So let's clear the screen. And next we'll run MiniKube start. And you can see here that it's creating a VirtualBox virtual machine with 2 vCPUs, 2 gigs of memory, and a 20 gig virtual disk. Now it says it's preparing Kubernetes 1.16 with Docker 18.09, and then we're pulling images and launching Kubernetes. We're waiting for the API server, the proxy server, the etcd service, the scheduler, and DNS, and then there we go. MiniKube has successfully started, and it tells us there that kubectl is now configured to use MiniKube. So Kubernetes control, or kubectl, was also installed along with MiniKube. Let's clear the screen, and then if we run kube control get nodes, you can see here we have a single node running. It's called MiniKube. Its status is ready. It is a master node, but in this case, it can also run our workloads, and it's running Kubernetes version 1.16. Then if we type Docker and run Docker, you can see we do have access here to the Docker command. And I should point out that it's not critical to be able to run the Docker client and talk to a Kubernetes cluster, but it's very common. If you're running Kubernetes workloads, most likely, or most of the time, they're going to be Docker containers, and so it's nice to be able to have access to the Docker client that can talk to the Docker server that's running in the MiniKube virtual machine over in VirtualBox. However, if we type Docker PS, you can see we get a nasty looking error. So how do we fix that nasty looking error? The Docker client should be able to communicate with the Docker daemon, but at this point it can't. Well, fortunately, MiniKube has a solution for us in this case as well. If we type MiniKube docker-env for environment, that's when we get this set of commands. And notice that these are Windows commands, but this command alone does not fix our Docker client to talk to the Docker server. What we actually need to do is to take the final command line string of this list of commands provided by MiniKube docker-env, copy them, and then paste them in, and that'll actually configure our local Docker client to talk to the Docker server that's running in the MiniKube virtual machine. So with that, we've reached the end of this lesson. I hope you learned how easy it is to deploy MiniKube in Windows. I hope you'll join me in the next lesson. Hello, Cloud Gurus. MiniKube is one of the most popular ways for creating a Kubernetes lab and learning environment on your local desktop or laptop computer. In this lesson, you'll learn how to deploy MiniKube on a Mac OS system. We've got a lot to cover, so let's get started. At a high level, the steps to deploy MiniKube on a Mac are first, to make sure that virtualization is supported in your CPU, and 99% of the time it is, especially on newer systems. But it's always good to fulfill this prerequisite and make sure that everything's going to work before you get started. I'll walk you through how to use the sysctl command to do that in just a minute. The next step is to install a hypervisor, but this isn't as hard as it sounds. In fact, it can be done with a single command. The default hypervisor is VirtualBox, but VMware Fusion can also be used. In just a moment, I'll walk you through installing VirtualBox using just a single command. From there, you install MiniKube, install kubectl or kubecontrol, and then finally start up MiniKube. To do that, we'll check to see if virtualization is supported with sysctl-a, pipe that to grep, -e --color, and what we're pulling out are the machine dependency CPU features, and specifically looking to make sure that VMX is available. After that, we'll use brew, which is a package manager for Mac OS, to install VirtualBox. If you don't already have brew installed, just point your web browser to brew.sh, and from there you can get the single command that you can use to install brew. It's a really handy tool, and once you have it, there are thousands of packages that you can easily install and uninstall with just a single command. So we'll use brew cask install VirtualBox at the command line to get VirtualBox installed. From there, we'll use brew cask install MiniKube to install MiniKube, and then brew install Kubernetes CLI to install the kubectl or kubecontrol command, and then brew install Docker to install the Docker client. We'll start up MiniKube with MiniKube start, and finally we'll configure our Docker client to talk to the Docker server that's running in MiniKube. And I should point out that installing the Docker client and configuring the Docker client are optional steps, but it's very handy to have both kubectl and the Docker client available to help you to manage your Kubernetes pods and your Docker containers that are running in the MiniKube Kubernetes cluster. We're here in the lab at the command prompt, and I encourage you to follow along. The first thing that we're going to do is to check to see if virtualization is supported. To do that, I'm going to use the sysctl command, -a, we'll pipe that to grep, -E. We're going to use the color option to color code what we're looking for here to make it easier to find. And we're going to look for machine CPU features with a pipe and VMX. And take a look at that. It says that VMX, or the virtualization features or virtualization extensions, are supported by our CPU. So we're good to go on that. That is just a prerequisite that we need to make sure that we check on. The next thing we need to do here to start the installation is actually to run brew cask install VirtualBox. And VirtualBox is going to be our virtualization hypervisor that's going to run the MiniKube virtual machine, which will actually have Kubernetes running inside. Again, if you don't already have brew installed, I recommend you point your web browser to brew.sh, press enter, and that'll give you the single command line option that you use to install brew. It's super easy. Once you have brew installed, it makes package installation very easy. It's going to allow us to install not only VirtualBox, but also MiniKube, kubecontrol, and Docker. And look at that, VirtualBox was successfully installed. I like that. That was easy. We installed VirtualBox with a single command. We didn't have to bring up the GUI and click next, next, next. And that was the first step that we need to perform to get MiniKube installed. So if we clear the screen, the next step is to run brew cask install MiniKube. And that's it. That's how fast and easy it was. Now, I had already downloaded MiniKube in a previous test, so that's why this happened so quickly. When you perform the installation, it might take a couple minutes longer, but make sure you watch for that final line right there that says MiniKube was successfully installed. Now, I should point out that when we installed MiniKube over in Windows, kubectl or kubecontrol which is our Kubernetes client that we use for administration, was also automatically installed. But that's not the case when you install MiniKube on your Mac OS system. And because of that, before we start up MiniKube, we're going to do brew install Kubernetes CLI, which is kubectl. And we get an error at this point. It tells us that the following directories are not writable, specifically user local include. And you may or may not get this message. In our case, we did. So I'm simply going to mark this, copy it, and then paste this in, which will change the ownership to the user that I'm logged in with. And then we'll make sure that our user has write permissions to that same directory by simply copying and pasting in the change mod command. So now if we clear the screen and we restart the installation with brew install Kubernetes CLI, we don't get the error message this time. We downloaded kubectl and we successfully installed kubectl. Now I know we got a little bit of an error down here at the bottom, but this was actually related to the brew cleanup, which is really unrelated to installing kubectl. Let's clear the screen and let's run kubectl, and indeed kubecontrol does work for us, so we don't have a problem there. And then the final installation that we need to perform, although it's not completely required just to run MiniKube, is to install the Docker client. And we'll do that with brew install Docker. This is the Docker client that's going to be talking to the Docker server that's running in the MiniKube virtual machine. With that installation complete, let's clear the screen and let's run Docker. And we do get the typical Docker output. However, I'll tell you in advance, once we start up MiniKube, which includes the Docker daemon running inside, our Docker client won't be able to talk to that Docker daemon by default. And because of that, let's type MiniKube here, and you can see all the commands that are possible. We need to run one of these commands, which is right up here, docker env. That will set up our Docker environmental variables so that our Docker client talks to the Docker server or Docker daemon running in the MiniKube virtual machine. So let's clear the screen and let's do MiniKube docker env. And here we go. It tells us we actually have to do this once our MiniKube virtual machine is running. So let's clear the screen and let's do a MiniKube start. And this actually creates the VirtualBox virtual machine. You can see it's going to have 2 vCPUs, 2 gigs of memory, and a 20 gig virtual disk. We're now preparing Kubernetes 1.16 and Docker 18.09. We're pulling images and launching Kubernetes, then starting up the API server, the proxy server, etcd, the Kubernetes scheduler, controller, DNS, and there you go. We successfully started up MiniKube, and it tells us that kubectl is now configured to use MiniKube. If we clear the screen, let's type kubectl space get space nodes. And there you go. You can see the name of our single node that's running is MiniKube. Its status is ready. It's a master node, and it's running Kubernetes version 1.16. Let's try another test here. Let's do a Docker PS. And it looks like our Docker client cannot talk to the Docker server running in the MiniKube VM. To fix that, we're going to run a MiniKube docker-env, and this tells us the command to use, which is this eval MiniKube docker-env right here, to actually configure our Docker client to talk to the Docker server. So we'll paste that in. We immediately get a command prompt again, and now let's try Docker PS again. And there you go. You can see that the Docker server knows that there are multiple containers running, and you can see that all of these relate to Kubernetes. That's because this is the Kubernetes master, and there are many different pods which contain containers running to provide all the Kubernetes master services that are required. To summarize, we first checked to make sure that virtualization was supported by our CPU, and then we installed VirtualBox. We installed MiniKube, we installed the Kubernetes CLI, we installed the Docker client, we started up MiniKube, and then optionally, we configured the Docker client to talk to the Docker server running in VirtualBox. We now have a working Kubernetes master with a working kubectl and working Docker client. And the rest of the course, we'll be spending most of our time in the lab environment. I think you're really going to enjoy it. I'll see you in the next lesson. Hello, Cloud Gurus. It's time to deploy your first application into Kubernetes. That's right. We're going to start an application, get it up and running inside Kubernetes, all in this lesson. And by the end, you'll see just how easy this is to do. To do this, we'll start off by creating a deployment called Web1. And inside that deployment will be a pod. And in that pod will be the Nginx web server, which is a very popular open source web server if you're not familiar with it. We're going to use an image called Nginx demos/hello, which is essentially a demo image for the Nginx web server that's going to show us the name of the container that web server is running inside. So just remember, as we talked about earlier, in Kubernetes you create deployments, inside deployments are pods, and inside pods are containers. And those containers run our company's applications. From there, we'll scale up the deployment. Why? Because we can. Kubernetes makes it super easy. With this single command, we'll go from having one web server running in a single pod in the deployment to suddenly having 20 web servers running in that deployment. Normally, it would be very difficult to scale up to 20 web servers or even 200 or 2,000 web servers, but Kubernetes makes this easy to do with a single command. This is exciting stuff. After that, we'll expose the deployment to the network, and this is a little bit more of an advanced topic since we haven't gone much into networking at this point, but the purpose of exposing the web server deployment and creating a load balancer is to allow us to test these 20 web servers. From there, since we're running Kubernetes in MiniKube, we need to run the MiniKube service web1 command, which is the name of our deployment. This will give us the URL that we can use to access our load balancer for the entire web server farm so that we can test our web servers, and I can prove to you how successful this really is. So with that, let's jump over into the lab environment, and I encourage you to follow along. What we'll do to run our first application in Kubernetes is to run kubectl create deployment, and we'll use the image nginx demos/hello space web1. Web1 is going to be the name of the deployment, and while we could just run the Nginx web server by itself, I really like the Nginx demos/hello image because it's going to give us information about the container that the web server is running inside. With that one command, we've deployed our first application on Kubernetes. It tells us that our deployment, web1, was created. If we type kubectl get deployments, you can see we have one deployment up and running called web1, and all of the pods in that deployment, 1 out of 1 at this point, are up and running in a ready state. If we type kubectl get pods, you can see we have one pod running. It is in a ready state, and its name is web1 with an automatically appended GUID string. So now what if we wanted to scale this up from just a single pod or a single web server running in our deployment to 20 pods or 20 web servers running in this deployment? If we do a kubectl get pods -w to watch, you can see that these 20 pods are being created, and very quickly they're all up and running. If we do a Control-C, let's clear the screen, and let's do kubectl get pods, and you can see we now have 20 web servers all up and running. That's how easy it is to massively scale applications with Kubernetes. If we do kubectl get deployments, you can see we have 20 pods that make up this deployment, and 20 out of 20 are in a running state. So now if we wanted to test our web servers, we need to first expose those web servers by creating a service. This is going to allow us to access these web servers from a web browser on the network. By default, one group of containers doesn't really know how to reach another group of containers because IP addresses are constantly changing. And for that reason, we need to expose the deployment. We'll expose these on port 80, and we'll configure the type to be a load balancer. And by the way, it is case sensitive, capital L, capital B. And you should know that there are a number of different service types that you can create, with load balancer just being one of them. A load balancer service type assumes you have some sort of external load balancer, such as a load balancer in the public cloud. So that created our service called Web1. If we type kubectl get service, there you can see we have the Web1 load balancer created. And if you're wondering why the status of the load balancer is pending, that's because, as I mentioned, we're pointing to a cloud-based load balancer that actually isn't up. But that's not going to affect the tests that we're doing in this lesson. And now, because we're using MiniKube, we need to use the MiniKube service command with the name of the service. This will automatically open up our web browser and point it to the URL of the load balancer. And that's simply because Kubernetes is running inside the MiniKube virtual machine. So if we press enter on this, it brings up our web browser, and take a look at that. We have the Nginx web server up and running. The server name is actually the name of the container. That's going to correspond to a container. If we click auto refresh on this, periodically, this will be automatically refreshed, and you will probably see the name of the container change. However, if we add more load, we'll probably see the name of these containers change much faster. So let's get a few of these up and running. There, we can see all 4 web browsers that are up and running. They're all hitting the Kubernetes load balancer, and they're all accessing this web server farm. And there you go. Did you see that one just changed? And now all of them changed. So essentially, we're doing round robin, going across all the different containers that make up this Kubernetes deployment, which is being accessed by the exposed service on port 80. And periodically, you'll see the name of the containers change to a new container. There we go. There's another change again. And this is how our load is automatically being distributed to this Kubernetes web server farm. And that's how easy it is to get your first application up and running in Kubernetes. And we didn't just choose a super simple application either. We created a deployment with 20 web server pods. We exposed that deployment by creating a service on port 80. And finally, we tested the web server farm to make sure we could access these web servers via the load balancer. I hope you'll stick with me and join me in the next lesson, where we'll be bringing up more applications in Kubernetes. Hello, Cloud Gurus. In this lesson, you'll learn how to create deployments from manifest files. What are manifests? Well, you're about to find out. A manifest file is a separate metadata file for an accompanying file or group of accompanying files. So what does that mean? Well, it's a separate file that has some metadata about some other files. It's that simple. And in Kubernetes, manifests are created in either YAML or JSON format. These are simply just formats for creating the manifest file. And you might be saying, hey, David, I don't know YAML or JSON. I've never even heard of those people before. Well, no worries. The cool thing is that Kubernetes can create YAML files for you, or you can simply just download YAML files from the internet. And it's nothing to be afraid of. It's just a standard format for a simple text file. If you provide a YAML file to the Kubernetes API with kubectl, it'll be converted into JSON and then sent to the Kubernetes API for processing and implementation. So think of this manifest file as the instruction book that goes with a Lego set. It tells you exactly how to put the blocks together to make the final product. And that's really what you're providing to Kubernetes, this manifest file that's going to be the instruction book for what could be either a very simple application or a very complex application with perhaps hundreds or thousands of pods and services and storage and policies. And the cool thing about manifest files is that they're human readable and they serve as great documentation. So I can create a manifest file on my local laptop. I can then send that up to the Kubernetes cluster, create a new deployment from that manifest file, and it's going to look exactly as it did on my local laptop. When it comes to Kubernetes, you really have two different options for running your applications. However, because of Kubernetes design, it's really going to push you into the declarative model. But first, let's talk about the imperative model. So in the imperative model, you tell the API what you want it to do using the kubectl command. For example, kubectl, run this pod. It's going to create a new pod called Nginx, and it's going to use the image Nginx. Kubernetes doesn't have to think about that. You said specifically, run this pod, and it will. And I think of this like Captain Picard on Star Trek. There are times when he says, fire photon torpedoes, and they fire the torpedoes. To me, that's the imperative model. So with Kubernetes, we're saying, Kubernetes master, run my pod. And that's what Kubernetes will do. By comparison, we also have the declarative model or declarative method here. And this can also be called desired state configuration or DSC. And I know that's a term, if you're from the Windows world, that term may be familiar to you because it's typically used with PowerShell scripting. But it applies very well to Kubernetes and the declarative model because what we do is we provide a manifest file, which is just a simple text file, and it contains the instructions or the blueprint that tells the Kubernetes master via the Kube API exactly what we want the master to do for us. And oh yeah, we want the master to ensure that that blueprint is exactly how we specified it at all times. And we do this with kubectl apply to apply with -f a manifest file. And I'll show you how to do this in just a minute. And the basic idea here is to simply say, hey, Kubernetes master, I want to make sure that this group of 5 web servers with 2 database servers are running at all times with some number of exposed ports with these specific resource allocations. And if they aren't healthy and if that exact number is not running at all times, then oh yeah, go ahead and restart them for me. And I picture this again like Star Trek, where Captain Picard in the declarative model says, hey, first officer, hey, number 1, send an away party down to the planet and go rescue our hostages. And sure enough, the first officer will always come back and do exactly that. But he also might have to think on his feet at some point to make sure that what he was ordered to do is indeed accomplished. And that's what the Kubernetes master can do for us. And the great thing about the declarative model is that this is awesome for reproducible configurations. It's great for documentation. I can create this manifest file of everything I want for my complex application, and I can apply that manifest file to Kubernetes on my laptop or up in the public cloud or in my data center, and no matter what, it will be implemented in the exact same way every time. So speaking of desired state, let's say that I have a single deployment here with pods inside. Maybe it's running my company's e-commerce application. Kubernetes is constantly monitoring the actual state of the application, making sure that it matches the desired state and that everything is okay. Maybe there's another deployment over here and Kubernetes is monitoring the actual state of that deployment, but it doesn't match the desired state that was in our manifest file. Kubernetes will take action to ensure that the actual state matches the desired state. So it might start additional pods. It might stop pods if there's too many pods. And this is that declarative model that we've been talking about. And now let's go into the lab. And if you'd like to follow along with this, you're welcome to do so. But I should caution you that what we're doing here is advanced and probably not in line with a fundamentals course. But the purpose of showing you this is not for you to do it exactly as I show you, but to show you the power of the declarative model of Kubernetes and how you can use manifests to very quickly bring up complex applications. This might be a topic and a lesson that you want to circle back to after you've watched the entire course and try it for yourself at that point. Over in the Kubernetes documentation, they have a nice little example of deploying the PHP guestbook application with the Redis database. And to do this, they have a single Redis master to store the guestbook entries, multiple replicated Redis instances to serve the reads, and then multiple web front-end instances. And you might think, oh, gee, this is much more than I anticipated, deploying an application with multiple database servers and multiple web servers. But take a look at this. This is an example of a manifest file. It's in a simple YAML format. They provide multiple YAML files to do this. However, it is possible to combine everything that they do here into a single file. And instead of going through this with you, I've actually taken all the YAML files here that they provide and put them into an easy string of commands. So here's a list of the kubectl apply -f commands that they used with the specific URLs in the documentation to deploy each one of the different pieces: the Redis master, the master service, the Redis slave, the slave service, the guestbook front end, the guestbook front end service, and then finally to open up MiniKube and access the URL. What we're going to do is just simply copy all of these commands and bring up this very complex application. So here at the command line, I'm just going to paste this in, and let's just give it a second to complete. And now let's take a look at this, kubectl get deployments. And you can see we now have a front-end deployment, a Redis master, and a Redis slave. And notice how we have 0 of 3 front ends ready. We have 0 of 1 Redis masters and 0 of 2 Redis slaves. And what's happening here is that these are slowly being brought up. If I do a -w to watch, let's give it just a second, and it should update. Here we go. 1 front end is ready, then 2, then 3. Now we should have all of our services up and running. We'll do a kubectl get deployments, and you can see there we have 3 front-end web servers, 1 master server, and 2 Redis slaves. If we do a kubectl get pods, you can see there are the individual pods that are running each one of these different services. So by just pasting in a command string with a YAML manifest file, we were able to deploy 3 web servers and 3 database servers. So now let's test it out. Let's do a MiniKube service front end and take a look at that. There is the guestbook application up and running. I can type in Hello Cloud Gurus here, click submit, and we have our first entry in the guestbook. There we go. And that's how easy it is to deploy a very complex application using a YAML manifest file. So now let's go ahead and clean up the deployment that we just did. We're going to do a kubectl delete on each of the deployments, the 2 deployments and the 2 services. And with that, you can see that the deployments are gone, and so are the services. And now let's do one more example. And again, it's okay if you're not at the point of recreating these yourself in your own lab. The point here is just to show you the value of manifest files and the declarative model. So here again, in the Kubernetes documentation, they have an example of deploying WordPress and MySQL with persistent volumes. Now, I'm not going to go through all of this, but the basic premise is that you download a couple of YAML files, and then you use what they call a customization YAML file, which is essentially a single YAML file that points to other resources and might contain things like secrets or passwords. So what we've done here, and I'll share my notes with you, is to download the 2 YAML files using a curl command. And with those 2 YAML files downloaded, I've actually already created the customization YAML file with these commands, and then all we need to do is to run kubectl apply -k to specify a directory where the customization file will be stored. So we'll do kubectl apply -k, and last time, if you remember, we did -f for a YAML file. In this case, we're doing -k for a customization file, and yes, it's customization with a K. I know it drives me crazy too. And then you have to specify a directory where that customization YAML file will be stored. Press enter on that, and look at that. We created a secret. We created 2 services. We created a deployment and 2 persistent volume claims. So if we clear the screen, let's do a kubectl get deployments, and you can see we have a WordPress and a WordPress MySQL deployment. The WordPress deployment isn't quite ready yet, but soon it will be. we can do kubectl get pods, and you can see we have a WordPress and MySQL pod. The WordPress pod is currently in a container creating state. We also created some services. You can see the WordPress and MySQL services are there as well. And then finally, we created some persistent volumes. And this is so that the data for the MySQL database and WordPress web server is always available, even if these containers restart. At this point, both our WordPress web server and MySQL server say that they are ready. And with that, let's test out WordPress. Upon running MiniKube service WordPress, this is what we get. It might be familiar to you if you've ever installed WordPress. From here, we can go through the site title. We'll call it ACG Rocks. I'll give it a username of David. We've got a password there, which I'll copy and click Install WordPress. It tells us that WordPress has been installed. We can log in. And we are now indeed running WordPress, all based on 2 YAML files and a customization file that we created and then deployed with a single command, which was kubectl apply. And that's how easy it is to create complex applications using manifest files and then just a single command, kubectl apply. I hope you enjoyed this lesson, and I'll see you in the next video. Hello, Cloud Gurus. We've seen how easy it is to deploy applications in Kubernetes. Now it's time to talk about how to monitor your applications. And I can tell you it's easy to do in just a few commands. The first one that you've probably already seen, that is kubectl get pod or get pods. If we go to the command line, and again, we'll type kubectl get pods, and we see that we have 3 pods running there. Their status is running. We can see how long they've been up. We can see the name of each pod and how many containers inside those pods are ready. And you can actually abbreviate kubectl get pods in as little as get po or po. And there you go, you get the same results. And by the way, one of my favorite things to do is to create an alias. So you can create an alias for kubectl and just say that k equals kubectl. And now I can type k get po. And that way, in as little as 6 characters, I can get the status of my pods. Of course, if you wanted to go even further with an alias, you could do something like kp equals kubectl get pods. And now type kp, and there we go. And by the way, if you type kubectl get pods -h, and here you can see the full command line options for kubectl get. In fact, one of my favorite things to do is -o for output equals wide. And you actually have to spell it out there instead of just W. And that gives us additional information. You can see here the IP of these pods. You can see the node that the pods are running on and more. If we scroll up and look more at the help information here, of course, there's a lot you can do with kubectl get, but one of the cool things is kubectl API resources. And this will give you a complete list of all the resources that are available from the Kube API, and that's actually everything that you can get. So let's try it real quick here before we go back and talk about some other ways to monitor our applications. So I'll type kubectl API-resources, and this is a complete list of all the things that you can get. Probably more information than you need to know right now, but it's good to know that the Kubernetes API is really just an open book. You can get anything you want out of it, and there's a lot of flexibility on how you can display it. Another way to monitor your applications is to run kubectl get deployments. So we'll type kubectl get deployments, And that gives us a list of our deployments. You can see the status of those deployments, if they're up to date, if they're available, how long they've been running. And you can also use -o wide here and get additional information. The name of the images, the selectors, which are the labels that are applied to these deployments, and the names of the containers that are running inside. And you can actually abbreviate kubectl get deployments all the way down to kubectl get deploy. And of course, if you wanted to create an alias for it, you could do something like alias kd equals kubectl get deployments. So we've got kd for get deployments and kp for get pods. That's cool. Another important command to know when it comes to monitoring your applications is describe. You can describe your pods and you can describe your deployments. Let's give that a try. So let's clear the screen and type kubectl describe pods. And here we get information on every pod, which you can imagine on a cluster that had many pods, you get a lot of output here. So why don't we just describe a specific pod? For example, let's select this web server right here. We'll take the name of the web server, clear the screen, and we'll type kubectl describe pod, a specific pod, and the name of the pod. We'll just paste that in. Now we just get information on that specific pod. So if we start at the top, let's look at what we get. We get, of course, the name of the pod, which we just provided, the namespace that the pod is running in, the node that the pod is running on, when it was started, any labels that are associated with the pod, and we haven't talked about labels yet, but labels are a great way to identify your pods. We get the status of the pod, the IP address of the pod, what it's controlled by. In this case, it's controlled by a replica set, and that replica set is controlled by a deployment. We get the container ID, we get the image name that's used in the pod, any ports that are open, when it was last started, the reason it was last terminated, any mount points for data, conditions, volumes, secrets, and then finally any events that are associated with the pod. And describe is a very powerful command because, as we said, you can do not only kubectl describe pods, but also kubectl describe deployments. And so I just specified all deployments at that point. If we scroll up a little bit here, let's look at one of these deployments. So this is the WordPress MySQL deployment. You can see any associated labels here, the status of all replicas, the containers that are running inside, the ports that are configured, environmental variables that might be set, mount points, volumes, and any events associated with this deployment. So you get a ton of good info there. kubectl describe is a very powerful command, and of course it makes us wonder, what else can you describe? Well, if we just type kubectl describe, it tells us we have to specify the resource that we want to describe. And we can find that list of resources by doing kubectl API-resources. And that's something we already did. You saw the very long list of resources that are supported by the Kubernetes API. And really, we can use describe to describe any of those resources. For example, we can describe services. We can describe persistent volume claims, and much more. Again, anything that's supported by the Kubernetes API, pretty much you can describe. And then the last method of monitoring your applications that I want to point out is the ability to view logs, kubectl logs, and then the name of the pod. Let's give that a try as well. Let's clear the screen and type kubectl. Let's just try logs, and it tells us that it's expecting either a pod or a type/name. So if we type kubectl get pods, or remember our alias kp, we get the pod names there. Now let's type kubectl logs, and then we need to specify the name of a pod. And so we can easily copy the name of a pod, paste it in there, and if there are logs, we get logs for that pod. In this case, there weren't any logs, so let's try it on a different pod. Let's try this WordPress pod here. And there we go. That one has some logs available to us. If we scroll up, you can see here these are actually logs from WordPress. WordPress was copied. There were some failures here related to MySQL. It recommends us to set the DNS name and some information here from Apache as well. And logs are a great way to troubleshoot when services aren't coming up that you expect to be up and available inside a container, which of course is inside a pod. So those are some great commands that you need to know how to perform when it comes to monitoring your applications running in Kubernetes. We've got a lot more to cover. I'll see you in the next lesson. Hello, Cloud Gurus. Let's talk about scaling up your applications. At some point, you're going to need more horsepower for whatever applications you're running for your company. You might need to go from running just one web server to 100 or even 1,000 web servers. And Kubernetes can make this super easy to do. For a little bit of background on how this works, Kubernetes uses deployments to do this. Deployments provide reliability, ensuring that a specific number of pods are always running. They provide load balancing because when you create a service, inbound connections will automatically be distributed across the pods running in the deployment, and they provide scaling. So you can easily reconfigure a deployment to run a higher or lower number of pods. When you create a deployment, it creates what they call a replica set. Now, you might find some documentation out there that talks about replication controllers. Replication controllers have been replaced by replica sets for the most part, and it's recommended that you only use replica sets, and that's what a deployment will automatically create for you. The great thing about deployments is that they use that declarative model, so you can have a YAML file that documents the pods and services and storage and policies that you want to bring up in your Kubernetes cluster. You say kubectl apply -f, point it to that YAML file, and that's exactly what will be created for you. And you have that documentation. You can take that YAML file anywhere else, run it in Kubernetes, and the exact same thing will happen. Deployments also allow you to perform rolling upgrades or updates. So when you need to update your application and run a new version of the application or a new version of the web server or database server, deployments make that possible with zero downtime. So we said deployments create replica sets. Replica sets are used to maintain a specific number of replica pods running at all times. And that replica set will actually add or delete pods as necessary. So if a few pods die for whatever reason, the replica set will add more pods, 2 more pods, to ensure you're always running the exact number that you specified. If somehow too many pods are running, the replica set will get rid of pods or kill off pods to, again, make sure you're running the exact same number of pods that you specified. And while you can easily create a replica set, it's recommended that you use a deployment to manage the replica set instead and let the deployment create the replica set for you. And now let's talk about another type of controller, and that is a daemon set or daemon set, however you want to pronounce it. I usually say daemon set, and if you think that's wrong, forgive me in advance. A daemon set is used to ensure that the same pod is running on all nodes in the cluster and that pod is started before other pods. So in Linux, you typically have daemons or daemons that run at all times, and these are kind of system services. Over in Windows, you have Windows services that run at all times. The daemon set Kubernetes controller was created for exactly this purpose. And this is great for logging or management agents that need to run on every node in the cluster. Another type of controller that you need to be aware of is the stateful set. Stateful sets are designed to run stateful applications, and in doing so, they maintain a sticky identity for each of the pods. This is really ideal for applications that need stable network identifiers, persistent storage, ordered deployments, and automated rolling updates. Now, since this is a fundamentals course, we don't really have time to go into how to create every one of these different controllers. We're going to primarily focus on deployments, but it's important to know what all these different controllers are and how each one has its own individual use case. I encourage you to use the links that I've placed in the resources section for this module to learn more about controllers. When it comes to scaling up your applications, you really have two ways to go about it, the declarative model and the imperative model. With the declarative model, you would go back and edit that YAML file that you created, that manifest file that documented what you wanted to run, and change the number of replicas to scale up your application, and then you would use kubectl update to update the deployment. The other way to go about it is to use kubectl scale. For example, we'll do kubectl scale deploy to scale a deployment, provide the deployment name, and then the number of replicas that we want. And it's even possible to do auto scaling with the kubectl auto scale command. We won't go into that, but it's really cool that this is even possible to scale the number of replicas or pods in your deployment based on the load that this application is under. So if we do kubectl get deployments, you can see we have 3 deployments out there. Let's take the web 1 deployment, and if we do kubectl describe deployment web 1, you can see here by default, the replicas are configured at just 1. 1 is desired, 1 is currently updated. There is 1 in total, and there is 1 available. There are 0 unavailable. Kubernetes is very clear when it comes to replicas. And if we clear the screen, let's use that kubectl scale command to scale our deployment called web1, and we're going to do -- replicas equals, and let's say instead of 1 web server, we wanted 10 web servers running. And it says we just scaled our deployment. Let's do kubectl get deploy. You can see it says the deployment has been scaled. It now says 1 out of 10. If we do kubectl get pods, you can see there are now 10 web servers running, and get deployments, now we have 10 out of 10. So that's how easy it is to scale up your applications in Kubernetes. What if you wanted to scale back down? Easy. Let's go back down from 10 down to just 2. And now we'll do get deployments -w. And oh, it's too fast. It's already happened. We have just 2 pods running. So those other pods were very quickly terminated. And now we just have 2 web server pods running. As you can see, scaling in Kubernetes is super easy to do. I hope you'll join me in the next lesson. Hello, cloud gurus. If you're using Kubernetes, it's important that you understand services. And that's because services are the abstraction that define a logical set of pods and a policy to access those pods. And sometimes these are even called microservices. The reason that we need services is because that most Kubernetes pods are stateless, and that means you start up a pod, and when it dies, it never comes back to life. And the IP address associated with that pod doesn't come back to life either. So you can never rely on specific applications being on specific IP addresses. So how can one group of pods, for example, a group of front-end web servers, access another group of pods, for example, a group of back-end database servers? You can't trust the IP addressing, and honestly, DNS is just not that reliable in this use case. So while pods have their own unique IP addresses, those IP addresses aren't exposed outside of the cluster without a service. So while one pod can communicate with another pod on the same node, there's no inbound communication from the LAN or the network without exposing those pods. And there are really 4 different types of services and 3 that are most popular, starting off with cluster IP, and that's the default. If you create a service with a cluster IP service type, that service is only accessible intra-cluster or within the cluster. If you want a service to be available on the IP of the node that it's running on, you would use the node port service type. Then there's the load balancer service type, which exposes the service externally using a cloud provider's load balancer, Or if your Kubernetes cluster is not running in the cloud, you can define your own on-premises load balancer. And then finally, there's the external name load balancer, which creates a DNS CNAME record, for example, web.server.com. Now, you can either create services imperatively with the expose command, which I'll show you how to do in a moment, or declaratively using a YAML or JSON file. Now, it's probably beyond the scope of this fundamentals course, but most production clusters expose web-based applications, meaning HTTP or HTTPS, using what they call Kubernetes ingress controllers, which isn't really a service type, but it allows external access to the group of pods that are running the web-based application. Now, the simple command to see the status of your services is simply to run kubectl get service, or SVC. If you want to expose a deployment to the network, you can use the kubectl expose command. You specify that you want to expose a deployment, the name of the deployment, the internal port on that deployment, the port number that you want to expose it on, and then in this case, we're using the service type load balancer. Now, you can also, of course, create a service with a YAML file using the declarative model, simply by using kubectl apply -f, and then pointing that to the name of the YAML file that you created that defines the service. Now let's go over into the lab and I'll show you how to expose a deployment, and I encourage you to follow along. We're here in the lab, and if we do a kubectl get deployments, you can see we have the Web1 deployment that's been running since we created our very first Kubernetes application. If we do kubectl get service, you can see we do have 3 different services already created: the Kubernetes cluster IP, which is there by default, and then the WordPress load balance service, and the WordPress MySQL service, which is cluster IP. Both the WordPress and WordPress MySQL services were set up in previous lessons. What we're going to do now to expose our Web1 Nginx web server, of which there are 2, you can see up here there are actually 2 pods that make up that deployment, and both of them are ready. So what we need here is a load balance service that will distribute the load randomly between those 2 pods running our Nginx web server. What we're going to do is to use the kubectl expose command, and we're going to expose that deployment called web1. We'll do --port equals 80, because that's the port that those web servers are going to be expecting a connection on, and then the type is going to equal load balancer, and that is case sensitive, by the way. And there you go, we just created the web1 service. Let's do kubectl get service, and there you can see the web1 service was created. Now, normally you could access it on this IP right here that was created. However, since we're running MiniKube, and that cluster is actually in a virtual machine, we need to use MiniKube service, and then the name of the service, which will open up our web browser, pointing it to that IP right there, which is actually the IP address of the MiniKube virtual machine, and then the port that Kubernetes assigned for the load balancer on top of that IP. And here's exactly what that looks like. You can see we're pointed to that IP address, the IP address of the MiniKube virtual machine with the port number that was created for the load balancer. And that's going to point to the IP address where it says server. That's actually going to be the IP address of one of the pods that makes up this Kubernetes deployment. In this case, it's Nginx. And now notice randomly, every so often here, the IP address of the server will change. You can see right now it's .02. If we keep refreshing here, it'll take a few refreshes, but eventually we'll be connected to the other pod that makes up that deployment. There we go. You can see it just changed. Took quite a few random requests, but now the server address and the server name have both updated. So that's the fundamentals of Kubernetes services. We use services to expose a pod, or typically a group of pods, abstract away all the underlying IP address information, and typically do a load balance deployment across multiple pods that are providing the same service. I'll see you in the next lesson. Hello, cloud gurus. You're using Kubernetes to run your applications, and those applications are going to have data, and that data needs storage. So let's talk for a minute about storage in Kubernetes. Now, most applications that are run in Kubernetes are stateless applications. However, it is possible to run stateful applications as well. But with stateless applications, it's assumed that they die and they are never brought back to life. And any storage inside the container or pod is lost when that container dies. So you think about these deployments where you want to scale up and add 50 more pods running an application, and then later you scale down back to 25. You might even enable auto scaling so that the number of pods is constantly going up and down based on the load. And even if a pod crashes, when it's restarted, the data that was in that pod dies with the pod. And this is called ephemeral storage, and that's not going to work for stateful applications. Stateful applications need stateful storage, and even many stateless applications will still need to be able to share storage between the pods for the applications to function. Not to worry, Kubernetes has a solution for this, and it's called Kubernetes Volumes. And as usual, Kubernetes offers a lot of flexibility on this. There are many different types of Kubernetes volumes. In fact, too many to list on a slide. If we go over to the Kubernetes documentation, you'll see here, if we click on types of volumes, there are many different types of volumes available to you, including AWS, Azure, Ceph, Cinder, CSI, Flocker, GCE, Gluster, iSCSI, Local, NFS, Storage OS, vSphere volumes, and more. If we click on CSI though, I want to show you CSI because CSI is an important type of volume. This is the container storage interface known as CSI. And most storage vendors out there today have created what they call a CSI compatible volume driver. So if you have some kind of storage array out there, chances are it offers a CSI or container storage interface volume driver. Volumes are typically created using the declarative model with a YAML configuration file, and that's because volumes are a resource just like anything else in Kubernetes. Kubernetes has what they call a persistent volume, or PV, which is storage that has been provisioned by an administrator or dynamically provisioned using storage classes. And then a PVC, or persistent volume claim, is a request for storage by a user. So PVs are created and then PVCs are what consume the storage that was created. Some of the commands that you need to be aware of are kubectl get PV to get the list of persistent volumes that have been created, kubectl get PVC to get the list of persistent volume claims, and then you can describe both persistent volumes and persistent volume claims. Let's go over into the lab and I'll show you how some of these commands are used. I encourage you to follow along. To see what persistent volumes we have available to us, we're going to type kubectl get PV for persistent volumes. And by default, of course, you won't have any persistent volumes. The only reason that we have two persistent volumes listed here is that if you recall, in a past lesson, we deployed WordPress and WordPress MySQL, and to do that, we used manifest files. If we take a look at the persistent volumes that we have currently created, notice here that both of them are 20 gigabyte persistent volumes. They have access modes that have been configured to read, write, and they're currently claimed, which means that they're currently in use by the WP PV claim and the MySQL PV claim. You can see how long they've been in use, 3 days and 10 hours each. And again, these persistent volumes were created when we deployed WordPress and MySQL. And if we take a look at the YAML files here and scroll up, you can see there was a persistent volume claim right here that was created named WP PV claim. It's a read-write once volume and it's 20 gigabytes. And then down here, when we look at the deployment and the container specs, you can see the volume for this WordPress container is going to use this persistent volume claim called WP claim. And it's the same for the MySQL YAML file. It creates its own volume, and then the container inside claims that volume. If we clear the screen, and if we type kubectl get PVC for persistent volume claims, we can see there are the two persistent volume claims that were created from the YAML file. These are currently bound to specific persistent volumes, and they have the same capacity and access modes and age of the persistent volumes that we just looked at. Now we can also do kubectl describe on, for example, a persistent volume claim. And don't forget to add PVC in here for persistent volume claim. So we say kubectl describe PVC space and then the persistent volume claim name. And now we get a ton of details. Again, we see the volume or the PV that this PVC is mapped to. We can see the labels which map to the specific application. In this case, it's a deployment called WordPress. And we can even see the name of the pod that has mounted this PVC. Now we can also do the same thing if we copy the volume name here, and let's clear the screen. Let's do kubectl describe, and we will describe a PV and paste in the name of the PV, and then we get a ton of details on the persistent volume. Again, to create persistent volumes, we can simply do kubectl apply -f and then specify a YAML file with all the details on the persistent volume that we want to create. And in this case, it's a manifest file that contains not only a persistent volume claim, but also a deployment and a service. So those are the fundamentals of Kubernetes storage: persistent volumes, persistent volume claims. You can easily use the get command and the describe command to get all the details you need about persistent volumes and persistent volume claims. Thanks for watching, and I'll see you in the next lesson. Hello, Cloud Gurus. One of the coolest things that Kubernetes does, in my opinion, is give you this ability to update your applications in real time with no downtime. In this lesson, I'm going to walk you through the process of updating your Kubernetes applications. But before we do, let's talk about rolling updates in Kubernetes. Now, this comes about because your end users expect applications to always be up. They get this expectation from things like Gmail and Facebook, which always seem to be up. Well, guess what? Those web-based applications most likely run Kubernetes. I know that Gmail does. At the same time, your developers want to continuously deploy incremental application updates. And the great thing about Kubernetes is that you can use deployments to meet these challenges, because that's exactly what Kubernetes rolling updates do. They allow you to incrementally update your pods with no downtime. This is commonly done with Kubernetes deployments, but it also works with daemon sets and stateful sets. And you use the rollout command. So let's talk about the exact command line sequence. Let's first take a look at what deployments we have running. And you can see here, we do have the WordPress deployment still running. And right now, that's just a single WordPress pod. But what if we were to use kubectl scale deployment WordPress, and let's do replicas equals 5. And we'll do kubectl get deployments again. And you can see WordPress says that 5 out of 5 of the WordPress pods are updated and available. So there are 5 WordPress pods running. If we clear the screen, let's now pretend that we wanted to roll out a new version of WordPress. Maybe there's a new version out, and we want to deploy that version across the 5 pods running in our Kubernetes environment. So we'll do kubectl set image deploy /WordPress, and the WordPress image will now be WordPress 5, let's say. So we reconfigured our deployment, and right now you can see there are 0 of 5 WordPress pods running, and right now it says container creating pending, and then you see the very first pod there that says error image pull, and now they're all changing to error image pull, and then image pull back off, image pull back off. And there's obviously a problem here. So let's do a kubectl, describe, and let's describe one of these pods that has the image pull back off status. We have to put pod in here, kubectl describe pod, and the name of the pod. And then take a look at this. Failed to pull image WP5, pull access denied, or repository does not exist, may require Docker login. Basically here, it cannot find the image name, and that's because I'll tell you, there is no image called WP5. I just made it up, but it could be very common that someone mistypes the name of an image, or they simply don't have access to that image. So what do? We have 5 WordPress servers here that currently aren't running, and they're in an error state, but this could be 500 WordPress servers, and that would be a very bad day for our customers. So how do we fix this very quickly? Well, you do a kubectl, rollout, undo, and deploy WordPress, and very quickly, you'll see that our pods are rolling back to the previous image, the containers are being created, and those pods are up and running again, just that quickly, using the rollout undo command. Now we also have some other commands that can help us when it comes to rollout, like kubectl rollout history for our deployments. And here you can kind of track the history of the different rollouts that have happened. You can roll out to specific revisions if you wanted to do that. And that way you can roll out to certain points in time. Another command that's helpful to us when it comes to rollouts is rollout status. And rollout status requires that you specify a resource, for example, a deployment like WordPress in this case, and it tells us that the deployment WordPress was successfully rolled out, or in this case, it was successfully rolled back, right? So what if we tried that again? Let's just do an up arrow here to make this faster, and let's roll out again with a bad image. Again, this WP5 image, we're going to roll out. Let's clear our screen, and let's do this rollout status. And we can use this to check the status of the rollout to see how things are going. Well, we've already tried this once, and we know that the rollout was actually unsuccessful. It failed, right? Because it couldn't pull that image name. But if we were watching a rollout here with 50 or 500 images, this would be a great tool for us to track the progress of this rollout. Again, this rollout is not going to be successful, so we need to do a Control-C here. And then let's up arrow and go back to rollout, undo, and we'll undo the rollout. Let's check the status here, and you can see that it's actually rolling back, and it tells us that that rollback was successful. If we show our pods again, we can see that all 5 WordPress pods are running. If we show our deployments or get deployments, you can see that 5 out of 5 WordPress pods are indeed running. They're up to date and they're all available. So what we can do is we can do a little bit of research, find the right image name that we need to do the upgrade to, and then reperform that rollout, track the status, and make sure that it is successful. So that's how easy it is to use Kubernetes to update your applications with the rollout functionality. Thanks for watching, and I'll see you in the next lesson. Hello, Cloud Gurus. A really cool feature of Kubernetes is this idea of virtual clusters, and they're called namespaces. Now, namespaces aren't something that I would recommend most people who are new to Kubernetes start creating and using, but it's still important to understand exactly what a namespace is, because by default, there are a number of different namespaces, and all the Kubernetes system resources are running in a different namespace than what you have visibility to. So let's talk a little bit about namespaces. A namespace is a virtual Kubernetes cluster within the same physical cluster. So let's say that I create a pod or a deployment in my default namespace. The name of that pod or deployment has to be unique. However, that's not the case if I create a pod or a deployment in a different namespace, because it's in a different virtual Kubernetes cluster while still running in the same physical Kubernetes cluster. For example, let's take a look here at our namespaces diagram. Here we've got 3 nodes, and they're running a number of pods. In this example, we have one namespace called the Apple namespace, and these 2 pods are in that namespace. Then we've got another namespace called the Orange namespace. And again, 2 pods are in that namespace. Now, namespaces can contain other types of Kubernetes objects besides just pods, but we're just using pods in this example. Now, we could name the first pod in the Apple namespace Fruit. That name is unique in the namespace. We could also name the first pod in the Orange namespace Fruit as well, because it's unique within the namespace. It doesn't have to be unique across the cluster. However, if we go to name the other pod in the Apple namespace Fruit, that's not going to be possible because there's already a pod named Fruit in the Apple namespace. So we have to get rid of that name, and for example, we could call this pod Red. And then in the Orange namespace, perhaps we call the other pod Orange. Again, just some simple names for pods and simple names for namespaces to help demonstrate the fact that names must be unique within the namespace, but they don't have to be unique across the cluster. If you just have perhaps 5 or 10 Kubernetes users using a cluster, namespaces probably aren't something that you need to worry about at this point. But as your cluster grows and the types and number of applications grow, it may be beneficial to you to create new namespaces. By default, you'll have at least 3 different namespaces. They are the default namespace, which is where we've been creating all of our pods and deployments. The kubesystem namespace, which is where all the Kubernetes system pods run, and the kubepublic namespace, which is created automatically, and all users, including anyone who's not authenticated, can see what's running in the kubepublic namespace. By default, however, there's no pods running in kubepublic. And depending on what you have deployed in your cluster, you may have other namespaces, which you'll see here in our MiniKube cluster in just a moment. To help you view the status of your namespaces, there are a few commands you should know. The first and easiest command is kubectl get namespace. That'll show you what namespaces are available and currently configured in your Kubernetes cluster. You can also specify which namespace that you're referring to when you run common Kubernetes commands such as kubectl get pods. You can specify -- namespace equals kubesystem, for example. If you want to set the default namespace for your kubectl client, you can do kubectl config set context -- current -- namespace and specify the namespace. And that way, whenever you run any kubectl commands, they'll be run in the namespace that you configured. And finally, to check and see what your default namespace is, you can do kubectl config view and grep for namespace. Now let's jump over into the lab and work with namespaces. I encourage you to follow along. First, let's run kubectl get namespace. And here you can see we actually have 5 namespaces already configured. The default kubenode lease, kubepublic, kubesystem, and the Kubernetes dashboard. And these were all created by default when we deployed MiniKube. If we run kubectl get pods, you can see the pods that we have running in the default namespace. However, if I run the same command, kubectl get pods, and use -- namespace equals kubesystem, you can see there's a whole different list of pods that are running over in the kubesystem namespace. And those pods provide the Kubernetes master services. Let's say that I wanted to change my default namespace for my kubectl command. I can do kubectl config set context -- current -- namespace equals, and let's say kubesystem. It says the context MiniKube was modified. Now if we just type kubectl get pods, we don't have to specify the kubesystem namespace with -- namespace. We've set the default to kubesystem. Now if we type kubectl config view and we pipe that to grep namespace, you can see our default namespace is now set to kubesystem. If we up arrow and we go back and we set our namespace back to default, which is the default namespace, and type kubectl get pods, we're back in the default namespace. So those are the fundamentals of Kubernetes namespaces, a very cool feature of Kubernetes that allows you to create virtual Kubernetes clusters within the physical Kubernetes cluster. Thanks for watching, and I'll see you in the next lesson. Hello, cloud gurus. You may be one of those people who just loves the command line interface and loves CLI tools. And if so, that's awesome, because most of what you do in Kubernetes is using the CLI. However, there are some folks out there who would just really love to see a very visually appealing graphical user interface for their Kubernetes cluster. And that's exactly what the Kubernetes dashboard is. The Kubernetes dashboard comes from the same folks that create Kubernetes. This is not a third-party tool. And what the Kubernetes dashboard is a web-based Kubernetes user interface that provides the ability to deploy container-based applications from a graphical UI, management of cluster resources, and troubleshooting of your Kubernetes cluster. We're about to jump into it in just a moment, but first, what we need to do is to deploy the Kubernetes dashboard. And thankfully, this isn't something that takes a long time to do. In fact, with a single kubectl apply -f command pointing to the Kubernetes dashboard manifest file, you can deploy the Kubernetes dashboard on your Kubernetes cluster. And yes, it works fine locally on MiniKube as well in our test environment. In fact, since we're using MiniKube in our lab environment, you access the Kubernetes dashboard by running minikube space dashboard. And with that, let's jump over into the lab environment, and it's there that I'm going to show you how to use the Kubernetes dashboard, including the dashboard overview, how to manage workloads, services, how to view the status of your Kubernetes storage, as well as config maps, secrets, and the logs view. Here in our Kubernetes lab, and I encourage you to follow along, we have our Kubernetes node. It is a MiniKube node, and we have a few pods running, but not many. And we want to deploy the Kubernetes dashboard. So how do you do that? Well, we said you use kubectl apply to apply a YAML configuration file, and that exact YAML configuration file is going to come from a URL in this case. Here in the Kubernetes documentation, when it comes to the web UI, or the dashboard as it's known, if you scroll down, you can see the URL is available right here, and I'm not going to try to type this out. It's very long. I'm simply going to copy it, and then we'll go back to the lab and then easily paste it in. And you can see that we're downloading content from GitHub, specifically from Kubernetes. And in this case, it's dashboard version 2.0 beta 6. And you can see by the extension .yaml, this is a YAML manifest file. So we'll just press enter on that. And there we go. We just deployed the Kubernetes dashboard. It looks like we did get a little error there at the end regarding the cluster role binding being invalid, but again, this is a beta version, so that's probably to be expected. From here, we're going to launch the Kubernetes dashboard, and we said since we're running MiniKube, we'll launch that with MiniKube dashboard. And what this does is it immediately brings up the Kubernetes dashboard, and you can see that we're using the URL for localhost 127.0.0.1:5787, and this was actually created for us back here from the MiniKube dashboard command. So it verified the dashboard health, it launched the proxy, it verified the proxy health, and then it opened up the URL for the Kubernetes dashboard. So let's actually learn about the dashboard, we'll play with the dashboard, and then we'll come back to the CLI and we'll do a little bit more investigation into exactly what makes this dashboard run, what pods are running in Kubernetes, and what namespace are those pods running inside. Initially, when you launch the Kubernetes dashboard, you're brought here into the overview. This is the overview of your cluster, of your namespace. This is the overview of the cluster for the default namespace, which you can see right here. You can get a view into multiple namespaces from the Kubernetes dashboard. You can even get a view of all namespaces. We'll look at that in just a moment, but first, let's take a look here at the workload status. Thankfully, everything is 100% green for our deployments, our pods, and our replica sets. You can collapse this or collapse any of these panels, you can see the specific deployments we have running in this Kubernetes cluster. We have 3 deployments, a WordPress deployment, WordPress MySQL, and our Web 1 deployment. You can see the namespace they're running in, the labels, how many pods make up each deployment, and the status of those pods. And you can also see the image that these deployments are using. If you click on the actions, you can see how easy it is to scale a deployment here. I can scale this up from 1 pod to 100 pods or 1,000 pods, assuming my cluster can support that. I can also go in here and I can edit the deployment, I can delete the deployment, and then from here I can scroll down to the specific pods that are running in this namespace. You can see the status of these pods, the restart count, you can see how long these have been running, you can see any replica sets that are configured, and then any services you have configured, persistent volume claims for storage, and finally any secrets that you have configured. So the overview here gives you, just like it says, a complete overview of just about every type of Kubernetes object that you need to be aware of as a Kubernetes administrator that might be running in the namespace. From here, over on the left, you can actually scroll down into specific workloads. You can see the status of your workloads. This is just showing replica sets, pods, and deployments, but then you can scroll down deeper into cron jobs, daemon sets, deployments, jobs, pods that are running in the namespace, replica sets, replication controllers, and stateful sets. If we take a look at these deployments, for example, let's look at Web 1 right here. I can click on the deployment name. I can see when this deployment was created, how long it's been running, the rolling update strategy, pod status, conditions, associated replica sets, and any associated events. So this might be really eye-opening, I think, for a lot of folks out there who are new to Kubernetes, because if you're a visual person like me, it might be hard to really visualize everything that makes up the Kubernetes cluster. And I do like how the Kubernetes dashboard really organizes all the different Kubernetes objects and allows us to see every type of object that's out there, the status of those objects, what we've created, what's running well, and what isn't running well. You can go in here and configure load balancing, ingress, and services. You can configure config maps, persistent volume claims, and secrets. And this isn't a read-only tool. I can go up here and click the plus sign and actually create new Kubernetes objects from input just by typing. I can create from a file that I can upload, or I can create it from a form. For example, test. Give this pod a name. I'll say I want to run 4 pods and click deploy. And there we go. Using the namespace, I just deployed a new pod. You can see not everything is running perfectly now. We have 25% of our deployments are in a pending state. 57% of our pods were pending, but now everything's green. And you can see I have the new test deployment up and running with 4 out of 4 pods. These were started just 25 seconds ago. And everything is running well now. You can see in the event status here, we scaled up our replica set test up to 4. Now, if I go back and I click on scale on this test pod, what if I want to scale this up from 4 up to 14? Let's see what happens now. And there we go. We have a yellow status again. Things are pending. Replica sets are pending, 14%, and these pods are slowly being brought up. There we go. Faster than I can talk about it, we have scaled up from 4 pods up to 14 pods. And so that's how easy it is with a few clicks of your mouse instead of a few kubectl commands, or I should say a single kubectl command at the command line. You're able to use the Kubernetes dashboard to scale up and down. If we want to go down, let's go down to 1, your Kubernetes pods. All right, so we talked about how the Kubernetes dashboard helps us to manage our workloads. You can see we just scaled down there while I was talking, down to 1 pod. We talked about workloads. Let's go in and look at the status now of our cluster. Here you can see the different cluster roles that are available, the different namespaces that have been configured on this cluster, and all the nodes that are available. In this case, we just have a single node because this is MiniKube. That's all it can do, but that's okay. Obviously, we're able to do a lot here. You can see how much memory and CPU this node has and how much has been consumed. You can see any information about persistent volumes and storage classes. So if I go into this node, the MiniKube node, it's here that I can see, let's start at the top, the name of the node, resource information, IP address information, host name, system information, kernel, container runtime, operating system, Kubernetes version. And then here we get some of those really cool donut graphs where we can see CPU, memory, and pod allocation. We can see if we're having any performance issues, memory pressure, disk pressure, whether or not the kubelet is ready, and then status of our pods, as well as system events. Now, if I click edit on this cluster, I can edit the YAML or the JSON configuration and very quickly update the status of the cluster or the cluster configuration. And thus far, we've been looking just in the default namespace. I can actually change this to all namespaces. And then if we go into our pods, for example, we can see the test pod we created. There's WordPress, there's Web1, but then here are all the system pods. For example, the Kube Controller Manager, etcd, Kube Scheduler, Kube API, and take a look at this last one, the Kubernetes dashboard namespace. In fact, we can just go into that namespace, and there you can see the dashboard metric scraper and the Kubernetes dashboard are the two pods that are running. And these are in fact exactly what we deployed to make the Kubernetes dashboard work. And one of the cool things you can do is you can actually exec into a pod. If we go into pods and then click on a specific pod, we can actually exec here into a pod and perform commands inside that container. So there's really a lot you can do here with the Kubernetes dashboard, manage all your workloads, storage, load balancing, config maps, deployments, and much more. As you can see, it's super easy to deploy the Kubernetes dashboard. We just did that with the kubectl apply -f to the dashboard manifest file. And then what that did is it created a new namespace called the Kubernetes dashboard namespace. And then inside that namespace, it created two pods, the Kubernetes dashboard pod and the dashboard metric scraper pod. Thanks for watching this lesson on the Kubernetes dashboard. Stick with me, we've got a lot more to learn. Hello, cloud gurus. One of the most common things that any Kubernetes administrator does while administering containers and pods is gaining access to a shell running inside a container. And this is super easy to do. In fact, you do it with a single command, kubectl exec -it for an interactive terminal. And it's there you put in the name of the pod and then -- any command that you want to run. Now you can use exec without the -it and without gaining access to a shell and simply run a command inside a container. If you already know exactly the command you want to run, you can simply use kubectl exec, pod name, -- and the command. However, in our case, we want to gain access to a shell inside a container, an interactive shell, so we can type whatever commands we want. So in that case, we'll use the -it and we'll run bin bash, which is just a shell, inside a container. And I should point out that the double dash there is not required. It's only needed if you're running a command that has some arguments. However, in my opinion, it's always good to put it in just in case you end up having a command that does have arguments. So now let's go over into the lab and give this a try, and I encourage you to follow along. So we're here in our Kubernetes lab. Let's type kubectl get pods. We can see we've got a number of pods running here. Let's go ahead and use just that Web1 Nginx test pod that we created. And let's say that we want to gain access to inside the pod. We want to make some configuration changes. To do that, we'll run kubectl exec -it for an interactive terminal. And then here we'll put in the pod name. And since the name of the pod is Web1, but with some additional characters that have been automatically appended, we'll simply copy it, go down here and paste it in. That makes it a little bit easier. Then we'll type -- bin/bash. And what happened here? Well, we got an ugly error. It said that exec failed. There was no such file or directory called bin bash. And let's learn something from this, actually. Not every container is going to have bin bash inside. Maybe you're used to using the bash shell. Maybe you use a different shell. But not every container will have bin bash, and not every container will have the command that you want to run. In the case of this container, this is an Nginx container, and apparently it does not have bin bash. So let's just try bin sh. And there we go. We do get a command prompt now. So let's say that you had a Ubuntu Linux container running. It would certainly have the bash shell. But in the case of Nginx, we did not have bin bash. So we changed that to bin shell, or sh. And you can see here, it still works great. In fact, we can go in here and we can make some changes, perhaps in etc. Perhaps there's something that we want to edit. We can cat out the host file, and maybe we want to nano the host file. No, we don't have nano. What about vi or vi? Yes, we do have vi. So here we could vi hosts, and maybe we want to go down here and make some changes to something inside the host shell. Maybe add a new IP address in here, and then we'll save that. We'll cat out hosts, and now we can go ahead and exit out, and let's do kubectl get pods. And there you can see our pod is still running. And let's try this command again. If we up arrow back to the kubectl exec -it, and let's say that we just want to cat etc hosts, and we'll have to take out the -it because this isn't going to be interactive. We'll press enter, and there we go. We're able to exec this command inside the container, cat etc hosts, to check our work there. You can see we did indeed add a new entry to the etc hosts file by execing inside the container. So that's how easy it is to get a shell inside a container using kubectl exec. Thanks for watching, and I'll see you in the next lesson. Hello, cloud gurus. Anytime you have a large cluster with multiple pods, multiple deployments, perhaps hundreds or thousands, it's important to understand how to manage your resources. And that's what we're going to learn about in this lesson. When it comes to managing Kubernetes resources, you should know that Kubernetes allows you to control CPU and memory resources on a per container basis. You can also modify API consumption resources through the Kubernetes API server. However, most of the time you're going to be working with applications. Applications consume CPU and memory, and you may need to place limits on those resources. Kubernetes allows you to place limits on CPU and memory, and also request a certain amount of CPU and memory. And then those pods are scheduled by the Kubernetes scheduler based on their resource requests. Now, for us to be able to do this in our lab environment, we need to enable what's called the metrics server. And this is easy to do with our MiniKube lab. We simply run the MiniKube add-ons enable metrics-server command to enable the metrics server. Of course, you can always list your MiniKube add-ons with the MiniKube add-on list command. So let's go ahead and enable that metrics server. And once we get that running, we'll come back and we'll talk more about exactly how to configure CPU and memory limits on a per pod basis. All right, we're here in our MiniKube lab, and I encourage you to follow along. We're going to run MiniKube add-ons space list. And you can see here, these are all the add-ons that MiniKube has available for us to enable or disable. And you can see from a previous lesson that we do have the dashboard enabled. That was the Kubernetes web UI. In our case, what we want to do is to enable the Kubernetes metrics server. To do that, we'll run MiniKube add-ons space enable and then metrics dash server. And there we go. It tells us the metrics server was successfully enabled. So let's go ahead and do an up arrow here. And again, we'll list out the Kubernetes add-ons, and you can see right there, metrics server was successfully enabled. All right, so that's how easy it is to enable the metrics server with the add-ons enable metrics server command. Now let's go back to our slides and talk a little bit more about how this is going to help us. With the metric server enabled, we're now allowed to manage our resources, and this is done inside the pod YAML file. If you look specifically at the container spec, underneath resources, you can go in now and you can place limits on the amount of CPU and memory that a container can consume, and then you can also request specific amounts of CPU. And it's done with just a few lines there of YAML code. Kubernetes offers a number of different resource controls that we can put in place, including CPU limits, memory limits, page size limits, requests by CPU, requests by memory, and requests by huge pages. Kubernetes 1.16 also announced a new resource type for ephemeral storage, where you can manage ephemeral storage limits and requests. So how do you know what resources are available? Well, you can run the kubectl top node command, top pod command, or kubectl describe and a specific pod to find out the resource configuration for that pod. So now let's go over into the lab. We'll put some resource controls in place. We'll run the kubectl top commands and describe commands to manage our Kubernetes resources. We're here at the command line, and I encourage you to follow along. What I've done in preparation for this lesson is actually to create a YAML file called resource-test.yaml. And in this YAML file, if we scroll up, you can see here I've created a section underneath the container spec called resources, where we're going to limit this container to a single CPU while requesting a half of a CPU. Now, let me show you a little trick as to how I created this pod, because actually it's really handy. So if we do a kubectl get pod, you can see we have a number of pods running. If I want to create a new pod based on an existing pod, it's easy to do kubectl get pod, and you specify the pod that you're talking about. For example, let's do web1, and then -o space YAML. And this is going to list out the entire YAML configuration file for this pod. And so if we want to do that, I'm just going to up arrow, and I'm going to redirect that to resource-test2.yaml. And then with that YAML file created, I can edit it. Let's say nano resource test2.yaml, and then I go in here and I delete anything that I don't need. And over time, you'll learn exactly what you do need and what you don't need. And let's create a new pod from this YAML file called resource-test2, put it in the default namespace, and then the point being here that you can just go down and you can delete anything that you don't need. Of course, we'll leave the container spec in there, perhaps delete some of these other things here. And you definitely don't need the status because that's the condition for the running pod. We'll take out everything else. Then we can save this. And then we have our new YAML file, and we can create a new pod with kubectl apply -f resource test.yaml. And this resource test YAML is the one that I added the resource configuration on. So we've created a new pod. We'll get our pods. You can see resource test is running. That's the new pod we created. If we do a kubectl describe on the pod named resource test, forgot the word pod, describe pod resource test. If we scroll up, you can see here we have the CPU limit and CPU request that we put in place. So that's how easy it is to control and manage resources on your containers running in pods within your Kubernetes cluster. So now to view the status of what's going on with the resources of this pod, let's do a kubectl top node, and this gives us the status of the node. So you can see we have 12% CPU consumption, 47% memory consumption. If we do an up arrow, we'll do kubectl top pod, and this lists out all the pods that are running, and you can see there's the resource test pod that we created. If you want to just list out a specific pod, you can do that with the kubectl top pod and the name of the pod command. So let's see what happens to our resources as we scale up. We said that our current CPU consumption was 12% and current memory consumption was 47%. If we were to use kubectl scale -- replicas equals 50 on the deployment test, let's see what happens to the resource consumption on our node over time. And I'll tell you that the resource statistics here seem to be a little bit delayed. They aren't very real time, because if I do a kubectl get pod, you can see we are creating a ton of containers right now. We really scaled up this deployment. And if we do a top node, however, our CPU and memory really hasn't changed at all. Let's clear the screen. Let's give this another minute, and it might take 30 seconds or so. I don't know the exact refresh rate on these statistics. There you go. You can see it was maybe 15 seconds, and the kubectl top node statistics have really started to increase here. We went from 12% CPU to 46% CPU consumption, and from 46% memory consumption to 51%. And I'm sure that's just going to be increasing here if we give it a little bit more time. Now, our pod consumption really hasn't changed very much, because with pod consumption, we're talking about individual pods. So just a single pod. Unless you can get something happening inside an individual pod, you're not going to see a lot of resource consumption on a per pod basis. We're seeing a lot of resource consumption on a per node basis because we massively scaled up the number of pods. However, inside each individual pod, there isn't a lot going on in terms of resource consumption. So with that, we've reached the end of this module on managing Kubernetes resources. I hope you learned how easy it was to configure resources on a per pod basis, and then how to monitor those resources over time. I'll see you in the next lesson. Hello, cloud gurus. At some point, I'm afraid to tell you, you're going to have some trouble with your pods. Maybe you start a pod and it just won't start. So what do you do then? What's your next step? Well, that's exactly what we're going to cover in this lesson. I want to introduce you to some commands, and we're going to walk through all these commands in the lab: kubectl get pods, describe pods, kubectl logs, and kubectl exec. Of course, there's a lot of commands that you can use to troubleshoot pods, but these are what I call my go-to commands for pod troubleshooting. Now, before we jump over into the lab and work with some pods that are in trouble, I want to first run through the pod conditions. So pods go through various conditions. When you first start a pod, the pod is pending. Then hopefully the pod is running, and in that case, you don't have any trouble. And then sometimes you might see a pod that says succeeded. What does that mean exactly? Well, it means you started a pod, it ran, it did what you told it to do, and then it terminated. It ended because it didn't have anything else to do. So it won't be restarted, but it did succeed. So that's still a good status, assuming you didn't intend the pod to be restarted. But then sometimes you'll see a failed status. In that case, at least one container in the pod failed for one reason or another. And of course, you'd want to look at the logs to find out exactly why. And then finally, there is an unknown pod status. And typically this means that the Kubernetes scheduler cannot communicate with the node that's running that pod. So it can't get the status of the pod. It knows that a pod was running on that node, but it cannot communicate with the node, so it can't tell you the status. So those are the pod conditions or statuses that the pods can go through. And this is really called the pod lifecycle, or the lifecycle of pods in Kubernetes. But then the containers inside can also have their own conditions. They can be waiting to run for one reason or another. They can be running, which is a good thing, or they can be terminated. With all of that in mind, let's jump over into the lab, and I encourage you to follow along, where we'll do some pod troubleshooting. To troubleshoot our pods, we're going to start off with kubectl get pods, and you can see the pods that are running on this Kubernetes cluster. Now, of particular importance, notice two pods that are in a ready state of 0/1. That means no containers are running in that pod. It's unable to get those containers running for some reason. You can see the resource test pod has a ready status of 0/1, and its status is pending. And then we have the resource test 2 pod, also with a ready status of 0/1, and its status is image pull back off. If we update this periodically, you might see some changes there, but not so far. And I'll tell you up front that I actually broke these two pods just for this pod troubleshooting exercise. So we said the first command that we can run to troubleshoot a pod that's not in a running status and has some other error status is kubectl describe, and then pods or pod if it's a single pod, and then resource test in this case is the name of the pod. Now the first thing I notice is down here at the very bottom, it says events. And the event here is failed scheduling because 0/1 nodes, so no nodes are available, insufficient CPU. So what this means is that the Kubernetes scheduler could not schedule this pod. It was in that pending status because no nodes have the CPU that's required. Well, what CPU is required? If you look up here, you can see the requested CPU is 50 CPUs. So we do not have a node that has 50 CPUs. What they might have meant here is 0.5, which would be half of a CPU, also known as 500 milli CPU. So to resolve this pending status of the resource test pod, we happen to have the YAML configuration for the resource test pod, and we can just go in here and let's actually change this to just 0.5. We'll save that. And then let's go ahead and reapply kubectl apply -f resource test YAML. And we obviously made a mistake there. You can't apply a YAML configuration to an existing pod if resources are being changed. So what we're going to do instead is to delete the resource test pod, and then we're just going to recreate it. Now, if we get pods, there you go. You can see the status is now running. If we do a kubectl describe pod resource test, you can see the log file right there. It was able to pull the image, and then it was successfully scheduled to node MiniKube. If we scroll up, you can see we are requesting 500M, which is 500 milli CPU, which is actually half of a CPU. So the scheduler was able to find a node that had that and schedule that pod there. All right, so we were able to troubleshoot our first pod issue. By the way, to just show the logs of a pod, we can do kubectl logs, and then the name of the pod, resource test 2 in this case, and then we could drill down and specify the container name if we want to do that. In this case, there was just a single container, so we didn't need to do that, but we were able to immediately see the issue with our second pod. That pod is getting an image pull back off status, in other words, an error, and the error using the kubectl logs command that we were able to find is error from server, bad request, container hello in pod resource test 2 is waiting to start, trying and failing to pull the image. Well, what image is it trying to pull? Let's do a kubectl describe pod resource test 2, and here we get a little bit more detail. You can see it's trying to pull this image, which is a really long, ugly typo-looking image that I actually inserted in the image name. And as we suspected, it failed to pull this image. The error from the daemon was pull access denied, repository does not exist, or may require Docker login. And then we got an error image pull, then we got an image pull back off, and then the pod is in the back off status because it tried multiple times to pull this image and it doesn't exist. So how are we going to fix this one? Let's get our pods. And let me show you another command that actually wasn't on the list. kubectl edit. This is going to edit the pod resource test 2, and this is a live edit of the YAML file. And all we need to do is to go down here and let's fix this typo. This is using VI, by the way. Let's right quit this. and the pod YAML was edited. Now we'll get pods, and hey, there we go. We were able to edit the YAML of the pod. We fixed the image name, and then it was immediately able to retry and pull down that container. All right, and with that, you can see we successfully performed troubleshooting on our 2 pods. One was in pending status. It couldn't start because it couldn't find the resources. Another one was in image pull back off status because there was a typo in the image name. So that's how easy it is to troubleshoot pods in Kubernetes. We've got more troubleshooting to do. I hope you'll join me in the next lesson. Hello, Cloud Gurus. At one point or another, you might have trouble with Kubernetes nodes. Of course, it's much more common to have trouble with pods since you're going to have many more pods than you have nodes. But if you have trouble with a node, you need to know how to fix it because nodes typically run a lot of pods. Now, in our case, we're using MiniKube as our Kubernetes cluster, and a MiniKube cluster is going to be quite different when it comes to troubleshooting nodes than, let's say, a production Kubernetes cluster. So first, let's talk about troubleshooting master nodes in a production Kubernetes cluster, and then we'll move on to troubleshooting Kubernetes nodes in a MiniKube cluster. Now, in a production Kubernetes cluster, you have master nodes and just regular nodes. So first, we'll talk about master nodes. There are a few commands that you need to know of. First off, simply run a kubectl get nodes, and you can see very quickly the status of the nodes, both the master and the regular nodes. And then there are a number of log files that you can take a look at. The var log kube API server, the var log kube scheduler, and the var log kube controller manager log. And then if you need to troubleshoot a regular node, a regular Kubernetes node is not going to have the same kube scheduler and kube API server and controller manager. Instead, it's going to have the kubelet. The kubelet is basically the Kubernetes agent running on the Kubernetes node. So in that case, you can cat out the var log kubelet.log. You can also cat out the kube proxy service, which again is in var log kube-proxy.log. In our next lesson, we'll talk about using the Kubeadm command. The Kubeadm command allows you to initialize new nodes and join nodes to a Kubernetes cluster. So that may also be a great tool to help you to remove a node from the Kubernetes cluster and essentially rejoin. And then my final tip on troubleshooting Kubernetes nodes in a production cluster is to check out the node problem detector. This is over in GitHub/Kubernetes/node problem detector. You can check that out, and it is a tool to help you detect the problems with your nodes. Now, in our case, we're using MiniKube to run our Kubernetes lab. And in MiniKube, you're probably not going to be going in and looking at the logs for the Kubernetes scheduler or the Kubernetes API server. In the case of MiniKube, you have your own command set that starts with MiniKube that you can use to perform MiniKube status, see what's going on. You can check the IP of the MiniKube virtual machine. You can view the MiniKube logs with MiniKube logs. You can SSH into the MiniKube virtual machine with MiniKube SSH. You can run MiniKube version to see the version of MiniKube and Kubernetes that you're running. You can do kubectl cluster-info. And then as a last resort, which I have done before, you can actually just delete your MiniKube cluster with MiniKube delete. You can reinstall MiniKube with brewcask reinstall MiniKube, and then just restart your MiniKube cluster, and that will actually cause MiniKube to be downloaded again, Kubernetes to be reinstalled, Docker to be reinstalled, and you'll start fresh, hopefully without any trouble. So now let's go over into the lab and let's perform some node troubleshooting in our MiniKube cluster, and I encourage you to follow along. So the first command, whether or not you're running MiniKube or a large production cluster, if you need to troubleshoot nodes, simply do kubectl get nodes. And as you can see here, we have just a single node. Its name is MiniKube, and most importantly, the status is ready. If your node is not ready, you know that you've got a problem there. Also notice the role of this node. It is a master node. It's not just a regular node. This is the master node. And in a production cluster, you would have multiple master nodes. You can see how long this node has been running and the version of Kubernetes that it is running. Now, to expand on this command a little bit, you can do -o equals wide. And by appending that, you'll get additional information. So you also get the internal IP of this Kubernetes node, the kernel version, and the version of Docker. Now, since we're running MiniKube here, let's do a MiniKube status. And here you can see our host is running, that's the virtual machine. The kubelet is running, API server, and kubectl is correctly configured. You could also do a MiniKube IP to get the IP of the virtual machine that's running your Kubernetes cluster. You can do MiniKube logs, and this will output all of your MiniKube logs, really a ton of information here. And you can scroll up through here. Of course, all the standard output and filtering stuff applies. You can pipe this to more, you could pipe it to a file, you could grep that file for a specific string. You can do a lot with that. Something else you can do is MiniKube SSH. And this takes you into the MiniKube virtual machine. So at the command prompt here, I can do a ps -ef. I can see all the processes running on our MiniKube VM. If you scroll up, you can see some processes that you might recognize. We can see Nginx, Containerd, Kube API server, etcd, Kube controller manager, Kube scheduler. This is our master Kubernetes node, and it's also running all of our containers. So any containers we start, like Nginx, are running on this virtual machine as well. Now, while it's pretty common to use SSH to connect to a Kubernetes node and do some troubleshooting, it's probably not very common to SSH to the MiniKube node and do troubleshooting, although it is a handy tool if you should need it. It's easy to do here, MiniKube version. You can see the version of MiniKube that you're using, and then MiniKube cluster-info. And actually, that shouldn't be MiniKube cluster info. That should be kubectl cluster-info. There we go. So you can see with kubectl cluster info where the Kubernetes master is running, where kubeDNS is running. And if you need to get additional information here, you can do kubectl cluster-info space dump to get a full dump of anything that's going on in the cluster. And then finally, if just nothing's working, you can actually do a MiniKube stop. And with MiniKube stop, you can do a MiniKube delete, and that deletes the MiniKube cluster. And then you can do brew cask reinstall MiniKube, and it tells us MiniKube was successfully reinstalled, and then do a MiniKube start once again. This will recreate the VirtualBox virtual machine. We'll prepare Kubernetes and Docker, pull down new images for MiniKube, launch Kubernetes, and with that, we've got a brand new fresh installation of MiniKube and a fresh install of Kubernetes. You can see we don't have any pods running anymore. This is like wiping out and reinstalling your operating system. So obviously something that's great to do in a lab environment that you're having trouble with a node, but not something recommended, not something easy to do in a production cluster. So those are some tips and tricks for troubleshooting Kubernetes nodes, both in production as well as in a MiniKube lab environment. Thanks for watching, and I hope you'll join me in the next lesson. Hello, Cloud Gurus. In this lesson, we're going to be talking about a command called Kubeadm that every Kubernetes administrator should know about. We'll also discuss the difference between production clusters and the MiniKube Kubernetes cluster that we've been working on in this course. After all, I think I would be negligent if we went through an entire Kubernetes fundamentals course and we never talked about production clusters and the Kubeadm command that's used to initialize production clusters. I mean, MiniKube is a great tool for a local Kubernetes lab environment, but if you're going to work with Kubernetes at your company, you're not going to be running applications on MiniKube. So how are production Kubernetes clusters different? Well, first off, they're not going to be running inside a single virtual machine. They might be using virtual machines, but you're not going to have just one. You might have one for the master and a minimum of two for your nodes to run applications for a total of 3 virtual machines. But that would be a relatively small cluster, probably a lab environment. A production Kubernetes cluster, while still using virtual machines, would probably have 2 masters, perhaps 2 more etcd servers in a high availability configuration, and then multiple nodes, could be 10, 20, 50 or more, running your Kubernetes pods. And while they could be run on multiple virtual machines, they could also be run on multiple physical hosts or multiple cloud instances. Again, you'll have multiple masters and multiple nodes, probably etcd in a high availability configuration, and deployment of these production Kubernetes clusters is much more complex, with etcd typically broken out into its own highly available cluster. Now, it's fairly common for Kubernetes administrators to run the Kubeadm command. Kubeadm is a best practice tool for deploying a multi-node Kubernetes cluster, and the subcommands typically include init to initialize a cluster and join to join the cluster. So the init is run on the master, the join subcommand is run on the nodes to join the master. So again, the basics of Kubeadm are to initialize the master with Kubeadm init, then go to each of the nodes and use the Kubeadm join command with the join token that was generated on the master from the Kubeadm init. Now, since MiniKube is limited to just a single Kubernetes node, there's no way for us to use Kubeadm to join new nodes to the MiniKube cluster. However, a great way to get some experience with the Kubeadm command and joining nodes to scale up your Kubernetes cluster is to use the Play with Kubernetes lab that I demonstrated earlier in the course. For example, here at Play with Kubernetes, I've got a single master node, and if I add a second node, I can then join that second node to the cluster using Kubeadm join. The exact join command was provided, of course, up here by the master node. If we go back to the master node, and once that Kubernetes node is ready, which you can see it now is node 2, we can easily create a Kubernetes deployment that will run across these nodes, or node in this case, and then we can take that deployment and scale it up, and you can see now we're creating additional containers. And if we look at where these are running, you can see they're all running on node 2. Well, what if we run out of capacity on node 2? How do we get additional capacity? Well, we can easily add a new instance, and then we can join this instance to the Kubernetes cluster just as we joined our second node. So that's Kubeadm. It's a best practice tool to fast path the deployment of a multi-node cluster. It's not something that you'll use in a MiniKube cluster, but it is something that you'll use when bringing up new nodes in a production cluster or in some lab environments, such as Play with Kubernetes. I hope that you enjoyed this lesson, and I'll see you in our What's Next lesson coming right up. Hello, Cloud Gurus. You have reached the final lesson in this course, and it's entitled What's Next? Where do you go from here? Well, here's what I recommend. First off, some great resources. Check out the Kubernetes documentation and Slack channel at kubernetes.io/docs and slack.k8s.io. Make sure you continue watching more great Kubernetes training from A Cloud Guru. Check out the Kubernetes deep dive courses here at A Cloud Guru to continue with your Kubernetes training. And finally, keep practicing. If you haven't already, I encourage you to build a single node Kubernetes cluster with MiniKube. From there, build a multi-node lab cluster, perhaps on your local desktop or laptop or up in the cloud, and spend some time getting familiar with the Kubernetes CLI administration tools. And finally, thank you so much for watching my Kubernetes Fundamentals course. I hope that you had just as much fun watching this course as I did creating it. I love the power of Kubernetes, and I hope after watching this course, you've fallen in love with Kubernetes just like I have. Feel free to reach out and say hi on LinkedIn or Twitter, And again, thank you for watching this course.